Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a tool for you to practice your entrance exam question papers. There you will find a number of entrance exam papers with their detailed solutions and PDFs. You can also download our app. The link is available in the description box. So students, let's move towards today's paper. We'll be solving TS EAMCET 4 July, 4 August 2021 Shift 1 paper. We'll be solving the mathematical part of the paper, which is having about 100 questions. So let's start with 80 questions. Let's start with the 80 questions of this paper, mathematics section. Best of luck. Here we go. Question number 1. It says if f is a function from real to real numbers is defined as f of x plus y is equal to f of x plus f of y for all x comma y belonging to the real numbers and f of 1 is equal to 10, then summation r is equal to 1 till n f r whole square is equal to what? So you are given that f x plus y is equal to fx plus fy, and the second thing f of 1 is equal to 10, which can be written as 1 multiplied 10. Then what can f2 be written as? It can be written as f1 plus f1, that is 20, right? That is 2 multiplied by 10. Similarly, f3 can be written as f2 plus f1, that is equal to 20 plus 10, which is 30, which is 3 into 10. f4, f3 plus f1, that is equal to 30 plus 10, which is 40, or that is equal to 4 into 10. Similarly, moving, fn is equal to n into 10, right? Now you have to find out summation r is equal to 1 till n fr square. This is written as fr square, sorry, f1 square plus f of 2 square plus f of 3 square, so on till f of n square, right? So what was f of 1? That was equal to 1 into 10 square plus 2 into 10 square plus 3 into 10 square plus 4 into 10 square n into 10 square, right? Let's take the 10 square common from all of them. So 10 square, I'll take common. It will be 1 square plus 2 square plus 3 square plus 4 square till n square. Now, this is, so what is the formula for sum of squares of first n natural numbers, that is given by n into n plus 1 to n plus 1 upon 6. Here the value of n I don't know. So this is equal to 100 multiply n into n plus 1 to n plus 1 whole divided by 6, which is 50 upon 3, n into n plus 1 to n plus 1. So this is answer to the question. Let's check with the options. We have option C as the answer. Hope you got that. Next is question number 2. And again, a function problem. F is a function, real numbers to real numbers, is defined by fx is equal to 3x plus 3 minus raised to power minus x upon 2 for all x belonging to the real numbers, and it satisfy fx plus y plus fx minus y is equal to a into fx into fy. Then a is equal to what? Okay, so here you are given fx is equal to 3 raised to power x plus 3 raised to power minus x upon 2. Similarly, if I have fy, this will be equal to 3 raised to power y plus 3 raised to power minus y upon 2. Let's find out the product of the two. Fx into fy will be written as 1 by 4 multiply 3x plus 3 raised to power minus x, 3 raised to power y plus 3 raised to power minus y. That is equal to 1 by 4, 3 raised to power x, 3 raised to power y, plus 3 raised to power x into 3 raised to power minus 5. So I can write it like this also, right? So directly let's write it like this. 3x plus y plus 3x minus y plus 3 minus x plus y plus 3 minus x minus y. Okay. Okay, so this is equal to 1 by 4, 3 raised to power x plus y plus 3 raised to power minus x plus y plus 3 raised to power x minus y plus 3 raised to power minus x minus y. So, okay. Now, let's go with the LHS. Fx plus y plus fx minus y. So, fx plus y was given as 3 raised to power this plus minus x minus y upon 2, and f of x minus y is equal to 3 raised to power x minus y plus 3 raised to power minus x minus y upon 2. Let's add both of them. So you will have fx plus y plus fx minus y. I'll take 1 by 2 as the LCM. You will have 3x plus y plus 3 minus x minus y, 3 minus x minus y plus 3x minus y, 3 minus x minus y. Okay, so now see, this whole term and this whole term, they match. If you look at this, right? And this is equal, correct? So if I say this is something equal to x, and that means this is also x. So according to the question, fx plus y, not x variable is already used. So let's say this is equal to some g. So fx plus y plus fx minus y is equal to 1 by 2 into g, and fx into fy is equal to 1 by 4 of g. So that simply means fx plus y plus fx minus y is equal to twice of fx into fy. So this was equivalent to a fx fy, which simply means a is equal to 2. That's it. So you have option A as the correct answer. Hope you understood this. Let's move to the next question, number 3. For all n belonging to natural numbers, 1 upon 2 multiply 5 plus 1 upon 5 multiply 8 till 1 upon 3n minus 1 into 3n plus 2 is equal to what? So here in the question, 1 upon 2 multiply by 5, this can be written as 1 upon 3, 1 by 2 minus 1 by 5. 1 upon 5 multiply 8 can be written as 1 by 3, 1 by 5 minus 1 by 8. Similarly, 1 upon 3n minus 1 into 3n plus 2. This can be written as 1 by 3 into 1 upon 3n minus 1 minus 1 upon 3n plus 2. So you have to add all of them. Let's add all of them. So after adding all of them, that is 1 upon 2 multiplied by 5 upon plus 1 upon 5 multiplied by 8 till 1 upon 3n minus 1, 3n plus 2. This is equal to 1 by 3, 1 by 2 minus 1 by 5 plus 1 by 3, 1 by 5 minus 1 by 8 plus 1 by 3, 1 by 8 minus 1 by 11, so on till 1 by 3, 1 upon 3n minus 1 minus 1 by 3n plus 2. So I'll take 1 by 3 common, and 1 by 2 minus 1 by 5 plus 1 by 5 minus 1 by 8 plus 1 by 8, so on till 1 upon 3n minus 1 minus 1 upon 3n plus 2. So these will cancel out till here. And you will be left with 1 upon 3, 1 upon 2 minus 1 upon 3n plus 2. Let's take the LCM 1 upon 3. So 3n plus 2 minus 2 upon 2 into 3n plus 2. These will cancel and you will have n upon 2 into 3n plus 2, which makes the answer as n upon 6n plus 4. That's it. You got the answer as n upon 6n plus 4, which is option A. So option A is the correct answer to the question. Hope you understood this. Let's move to the next question, number 4. If the system of equations 3x minus 2y plus z is equal to 0 and lambda x minus 14y plus 15z is equal to 0 and x plus 2y minus 3z is equal to 0 has a solution other than x is equal to y is equal to z is equal to 0, then lambda is equal to what? So the given system of equations is 3x minus 2y plus z is equal to 0. Question number 4 is the system of equations. This, and this has a solution other than x is equal to y is equal to z is equal to 0. Then lambda is equal to what? You are given three equations, 3x minus 2y plus z is equal to 0 and lambda x minus 14y plus 15z is equal to 0. X plus 2y minus 3z is equal to 0. Now this can be written as 3 minus 2, 1, lambda minus 14, 15, 1, 2 and minus 3, x, y, z is equal to 0, 0, 0. That is of the form ax is equal to 0. So here, determinant of a is equal to 0 for non-trivial solution of homogeneous equations. Right. So that means mod of 3 minus 2, 1, lambda minus 14 and 15, 1, 2 minus 3 is equal to 0. Let's find out the determinant. This will be 3 into 42 minus 30 plus 2 into minus 3 lambda minus 15 plus 1 into 2 lambda plus 14 is equal to 0, which gives you 36 minus 6 lambda minus 30 plus 2 lambda plus 14 is equal to 0. Minus 4 lambda plus 20 is equal to 0, which gives you the value of lambda as 5. And this is what we needed to find out. That is option D is the correct answer. Hope you understood this. Next is question number 5. If delta is equal to determinant of this matrix and this is equal to k into a minus b into b minus c into c minus a, then k is equal to what? So simple as that, very simple. You are given delta is equal to 1a square, 1b b square, 1c c square. Right, let's find out. Do some operations first. You can write down R2 as R2 minus R1, R3, R3 minus R1. So this determinant will become, now this will be 1a square and 0 b minus a and b square minus a square, which can be written as b minus a into b plus a. Similarly, 0 c minus a, c square minus a square, which will be c minus a into c plus a. I'll take the common outside, that is b minus a and c minus a from these two rows, R2 and R3. So these rows will be left with 1a square, 0, 0, 1, 1, b plus a upon, not upon, sorry, c plus a. Okay, so this further is, now let's expand it. So this is b minus a, c minus a, and I'll use expand it along R1. So you will have c plus a minus b plus a, which will give you b minus a, c minus a, and these a's will cancel into c minus b. Okay, now let's do, this is equivalent to this given expression. So let's write this is equivalent to k into A minus B, B minus C into C minus A. Here is B minus A and C minus B. So let's take minus 1 into minus 1 common. This is A minus B, C minus A, and B minus C. This is equivalent to K into A minus B, B minus C, and C minus A. So this will be plus 1, right? Using that, you will find out the K's value as 1, which is the answer to the question. That means option A, B is the correct answer. Hope you understood this. Let's move to the next question then. Question number 6, if x is equal to alpha, y is equal to beta, and z is equal to gamma is a unique solution of the system of equations this, and this, then beta is equal to what? Let's write down these given system of equations in the matrix form. So this can be written as this is the first one. This is the first one. So this will be 5 minus 7 and 3. The second is 7x plus 10y minus 8z is equal to 3. So 7, 10 minus 8. And the third one is this. So this will be 2, 3 and minus 4. Here is x, y, z. Now this is equal to 0, 3 and 4 will come on this side. This will be minus 4. Correct? Now by the Cramer's rule, y is equal to beta, that is given by delta 2 upon delta. What is delta 2? This is equal to, I'll replace the second column with this. So the second column, which is the y column, will be replaced by this. Okay, so this is given by 5, 0, 3, 7, 3, minus 8 and 2, minus 4, minus 4. Let's find out the determinant. This is equal to 5 into minus 12, minus 32, minus 0, plus 3, minus 28, minus 6. That is 5 multiply minus 44 plus 3 multiply minus 34, which will give you the answer as minus 322. Now, what was delta equal to? This was delta. This one was your delta. Let's find out the determinant. So this is equal to 5 minus 7, 3, 7, 10, minus 8 and 2, 3 and minus 4. So this is equal to 5 into minus 40 plus 24, 7 minus 28 plus 16, 3, 21 minus 20. That will be equal to minus 161. So beta is equal to minus 322 upon minus 161, which will give you the 2 as answer. The value of beta is equal to option B, that is 2. Hope you understood this. Let's move to the next question then. Question number 7. If a plus iota b raised to power 1 by 4 is equal to 2 plus 3 iota, then 3b minus 2a is equal to. So you are given here a plus iota b is equal to 2 plus 3 iota raised to power 4. So this will come over here. This can be written as raised to power 4. Now let's open it up. You will have 4c0 into 2 raised to power 4 plus 4c1 into 2 raised to power 3 into 3 iota plus 4c2 into 2 raised to power 2, 3 iota square plus 4c3 2, 3 iota raised to power 3 plus 4c4 into 3 raised to power 3 iota raised to power 4. That is equal to 1 into 2 raised to power 4. 2 raised to power 4 is equal to 16 plus 4 into 8 into 3 iota plus 4c2 is equal to 6. So 6 multiply 4 multiply 9 iota square plus 4c3 can be written as 4 into 2 into 27 iota cube plus 4c1, this is 1 into 8, 1 iota raised to power 4. Okay. So let's solve it. Okay, now just have to do the calculation. 16 plus 32. This is 96. 32 into 3, this is 96 iota. minus iota square is equal to minus 1. So 6 into 4 into 9, this is equal to 216 minus 216 iota, because iota cube is equal to iota square into iota. Iota square is equal to minus 1. So this is equal to minus iota. Okay. And iota raised to power 4 is equal to 1. That gives you 81 over here. So adding all of them, you will get minus 119 minus 120 iota. Now let's compare it with A plus iota B. So A is equal to minus 119. Real part is equal to real part and the imaginary is equal to imaginary. So A is equal to minus 119 and B is equal to minus 120, which makes 3B minus 2A. So 3B is minus 120 minus 2 into question number 7. If A plus iota B raised to power 1 by 4 is equal to 2 plus 3 iota, then 3B minus 2A is equal to. Basically, I have to find out A and B values. So this expression can be written as A plus iota B is equal to 2 plus 3 iota raised to power 4. Now, expanding this, you have 4C0 into 2 raised to power 4 plus 4C1 into 2 raised to power 3 into 3 iota 4C2 2 raised to power 4. 2 raised to power 2 into 3 iota square 4C3 2 raised to power 1 into 3 iota raised to power 3 plus 4C4 into 3 iota raised to power 4. Okay. So what is 4C0? That's 1 into 2 raised to power 4 plus 4 into 8 into 3 iota plus 6 into 4 into 9 into, see, iota square is equal to minus 1. So I'll multiply this with minus 1 as well. Plus 4C3 is again 4 multiply 2 multiply 12 iota cube. Now what is 12 iota cube? That is equal to minus iota only. Okay. Iota cube can be written as iota square into iota. Iota square is minus 1. So that is equal to minus iota. Plus 4C4, that's 1 into 81 iota raised to power 4. And what is iota raised to power 4? That is equal to iota square into iota square. That is minus 1 into minus 1, which is 1. Okay. Okay, I'll write it in the next step. So this becomes 2 raised to power 4, that's 16 plus 96 iota minus 216 minus 216 iota. And this is equal to 81, which gives you minus 119 minus 120 iota. Let's compare it with A plus B iota. So real part is equal to real part, which makes A is equal to minus 119 and imaginary part is equal to the imaginary part, which makes B is equal to minus 120. You had to find in the question 3B minus 2A. So that makes 3 into minus 120 minus 2 into minus 119, which is equal to minus 360 plus 232. That is minus 122. That's the answer to the question. Let's check. You have option B as the answer. Hope you understood this. Now let's move to the next question number 8. Okay, here says W is a complex cube root of unity. Match the following of list 1 to the list 2. So the first one, we'll pick up all the questions which are given one by one. The first one is omega raised to power 1010 plus omega raised to power 2020. So this is the one which is given. This can be written as omega raised to power 336 into 3 plus 2. So if you will divide this with 3, you know one thing, omega cube is equal to 1. So if you divide 1010 with 3, you get 336 in the quotient and the remainder will come out to be 2. Plus omega raised to power 2020. Again, I'll do the same thing. I'll divide it with 3. So here will be 673 and you will get the remainder as 1. So this is equal to 673 into 1 into 3 plus 1, which can be written as omega cube raised to power 336 multiplied by omega square plus omega cube raised to power 673 multiplied by omega. You know that will be equal to 1. So omega square 1 into omega. You know, one more thing, 1 plus omega square is equal to 0, which makes omega plus omega square is equal to minus 1. So this is equal to minus 1. Okay. That means option A matches with third part. Let's move with the second one, this one. B part, 1 plus omega minus omega square, 1 minus omega plus omega square. So next, let's multiply. You have 1 minus omega plus omega square plus omega minus omega cube. Okay, wait. Omega minus omega cube and plus omega cube. Further, this is minus omega square plus omega cube minus omega raised to power 4. Now, this omega cube is equal to 1. These two will cancel out. And you have minus omega square. This will also cancel out. This is, you will write it down. Okay, these will also cancel down. And you have 2 omega cube minus omega raised to power 4 can be written as omega cube into omega. So this will give you omega only. Okay. Yeah. And this is also equal to 1. So 2 minus omega is there. Question number 8, omega is a complex cube root of unity and you have to match the items in the list 1 to the list 2. You have 4 questions over here. We will solve all of them one by one and see where do they match to the list 2. So first one is omega raised to power 1010 plus omega raised to power 2020. Before starting the question, let's discuss some of the identities. First one is omega raised to power 3 or omega cube is equal to 1 and 1 plus omega square is equal to 0. Now this, if I divide with 1010 with 3, you get the quotient as 336 and the remainder will be 2 in this case. So this can be written as omega raised to power 3 into 336 plus 2. Similarly, omega raised to power 2020, if I divide 2020 with 3, I get the quotient as 673. And you will get the remainder as 1. So this can be written as omega raised to power 3 into 673 plus 1. You know, okay, this is omega cube raised to power 336 into omega square plus omega cube raised to power 673 into omega. This is equal to 1 into omega plus 1 into omega square plus 1 into omega. So omega square plus omega. Using this particular identity, you know this is equal to minus 1. So this is option A. Option A matches with list and with the third option in list 2. So the second part, 1 plus omega minus omega square, 1 minus plus omega square. Okay, so 1 plus omega, that's equal to minus omega square, minus omega square. And 1 plus omega square, that's equal to minus omega. So this gives you minus 2 omega square into minus 2 omega. That will give you 4 omega cube, which is equal to 4 only. Okay, so that means this is part B. B question matches with the fourth part in list 2. Let's move with the third one. C, 2 plus omega square plus omega raised to power 4. So this makes it 2 plus omega square plus omega raised to power 4 whole raised to power 5. You can write it as 2 plus omega square plus omega raised to power 5. I can split it as 1 plus omega, 1 plus 1 plus omega square raised to power 5, right? You know, this is equal to 0. So that is equal to this. This gives you the answer as 1. So this is option C. Option C matches with the second part of the list B. Now let's go with the D part of it. So D part, it's 3 plus 5 omega plus 3 omega square. That is this whole raised to power 3. Now this is equal to, this can be written as 3 plus 2 omega plus 3. I'll take omega plus omega square common raised to power 3. This further can be written as 3 plus 2 omega plus 3 into, that's equal to, I write down once again, 1 plus omega square is equal to 0. So this is equal to minus 1 whole raised to power 3. These two will cancel out. And you have 2 omega raised to power 3, which gives you 8 omega cube or 8. So this matches with the option D, the fourth part. Right. Now let's look at that. It matches A is with third part. B is with 4. C is with 2. And D is with 5. So 3, 4, 2, 5. 3, 4, 2, 5 is option C. So this is the correct answer to our question. Hope you understood. Next is question number 9. If the roots of the equation z minus 4 whole cube are 8 iota and 2 minus, if the roots of the equation z minus 4 whole cube is equal to 8i are this, this and this. You have to find out the root of A, B, C. Okay. So you are given z minus 4 whole raised to power 8, 3 is equal to 8 iota, which you can write as z minus 4 is equal to 8 iota raised to power 1 by 3, which is 8 raised to power 1 by 3 into iota raised to power 1 by 3. That is equal to 2 into iota raised to power 1 by 3. Right? Now, iota can be written as e raised to power iota pi by 2. That is equal to e raised to power iota pi by 2. In the general form, it is written as 2n pi. So, I raised to power 1 by 3 is equal to I raised to power, I'll divide this with 1 by 3 as well. So, this will become pi by 6 plus 2n pi by 3, where n may have the values as 0, 1 and 2. So, e raised to power iota pi by 6, this actually is equal to cos pi by 6 plus iota sine pi by 6, right? Which is cos pi by 6 is root 3 by 2 and sine pi by 6 is 1 by 2. Okay, next e raised to power iota pi by 6 plus 2 pi by 3. So this was for the first time when I was putting n is equal to 0. Here is n is equal to 1. So this becomes e raised to power iota 5 pi by 6, which is equal to cos 5 pi by 6 plus iota sine 5 pi by 6. Cos 5 pi by 6, if on solving, will give you cos pi minus pi by 6. Similarly, here you will have sine pi minus pi by 6. Okay. Now, this lies in the second quadrant. Pi minus pi by 6, it lies in the second quadrant. And you know, cos is negative in that quadrant. So this will become minus cos pi by 6 and this will remain. Sine is positive in the second quadrant. So this will be sine pi by 6. This is equal to minus 3 by 2 plus iota 1 by 2. Okay. Now the next one for n is equal to 2 now. This will become e raised to power iota pi by 6 plus 4 pi by 3, which is equal to cos 3 pi by 2. This will be, okay, wait. This is equal to e raised to power, I'll take the LCM, 6. So pi plus 8 pi. That's equal to e raised to power iota 9 pi by 6, which will be giving you 3 by 2 pi. Okay. So now that's equal to cos 3 pi by 2 plus iota sine 3 pi by 2, which can be written as cos pi plus pi by 2 iota sine pi plus pi by 2. So now this cos lies in the third quadrant. Anyways, cos this is cos pi by 2 and minus, and this is equal to sign, minus sign. Third quadrant sign is negative. So this pi by 2. You know, cos pi by 2 is 0. So minus 1, that is equal to, iota was missing. I forgot. This is equal to minus iota. Okay. So now let's write down them segregately for n is equal to 0, 1, and 2. For n is equal to 0, e raised to power iota pi by 6. That came out to be root 3 by 2 plus iota into 1 by 2. And for n is equal to 1, e raised to power iota 5 pi by 6. That's equal to minus root 3 by 2 iota 1 by 2. And for n is equal to 2, iota raised to power 3, e raised to power iota 3 by 2 is equal to minus iota. Okay. So now what does the z becomes? It is 4 plus, that was equal to this, right? Using this equation. So z is equal to 4 plus 2 root 3 by 2 plus iota 1 by 2. That gives you 4 plus root 3 plus iota. And similarly, for the second, n is equal to 1, this z is equal to 4 plus 2 minus root 3 by 2 plus iota by 2, which gives you 4 minus root 3 iota. And now this is equal to 4 plus 2 into minus iota, which gives you 4 minus 2 iota. Okay. Now you are given that this is equal to a minus 2 iota, this and this. So let's compare them. These are the three roots. So 4 plus 3 plus iota, that's equivalent to b plus iota. Now this is equivalent to, let's say, c plus iota, and this is 4 minus 2 iota. So this is of course equivalent to a minus 2 iota. And what we have to find out from here, the value of a is equal to 4 and the value of b is equal to 4 plus root 3 and c is equal to 4 minus root 3. You have to find out the root of ABC. So that is 4 into 4 plus root 3, 4 minus root 3. That will give you 4 into 4 square minus root 3 square is 3. Okay, whole under the root. That gives you 4 into 16 minus 3, that's 13, which gives you 2 root 13 as the answer, which is option C. So option C is the correct answer. Hope you understood this. Next is question number 10. If A alpha upon alpha plus 1 and beta upon beta plus 1 are the roots of this quadratic equation, then the equation having the roots as alpha and beta. Okay. So first thing, you are given this equation, x squared plus 7x plus 3 is equal to 0. And the two roots are this and this. These are the two roots. Now equation having these two as the root. Sorry, equation having these two as the roots. Equation which have alpha and beta as the roots is this, right? So that means x upon x plus 1 whole square plus 7 into x upon x plus 1 plus 3 is equal to 0. Let's take the LCM. You will have the numerator as x square plus 7x into x plus 1 plus 3 into x plus 1 whole square is equal to 0. X square plus 7x square plus 7x plus 3x square plus 3 plus 6x is equal to 0, which is 11x square plus 13x plus 3 is equal to 0. That's it. You have this. So you want to have the equation which is having alpha and beta as the roots. That is 11x square plus 13x plus 3 is equal to 0, which is option B. Hope you got that. Next is question number 11. If y is equal to this expression, which is written by, let's write it down. Y is equal to x square plus 14x plus 9 upon x square plus 2x plus 3 for all x belonging to R, then the interval of maximum length in which y lies is. I'll start with this expression. So let's do the cross multiplication. You can write it as yx square plus 2yx plus 3y is equal to this, right? I'll take everything on the left hand side. You can write it as y minus 1 x square plus 2y minus 14x plus 3y minus 9 is equal to 0. Now here x belongs to the real numbers. If x belongs to the real numbers, that means discriminant is greater than equal to 0. Then only x will belong to the real numbers. So if the discriminant, it's given by b square minus 4ac. So b square minus 4ac is greater than 0. This is b, a, and c. So 2y minus 14 whole square minus 4 into y minus 1 into 3y minus 9 should be greater than equal to 0. I'll take the 3 common from this side and 2 from here. So 2 square, that is equal to 4 y minus 7 whole square minus 12. I'll take 3 common from here. So this is y minus 1 and y minus 3. Okay, greater than equal to 0. I'll take the 4 common now from the whole. Y minus 7 whole square minus 3 y minus 1 y minus 3 greater than equal to 0. That means I'll open, see the 4 will go and divide by the 0, so it will go away. And I'll take the inside of the brackets only. This is y square minus plus 49 minus 40y minus 3 y square minus 4y plus 3 is greater than equal to 0. Or after opening the brackets, you will get minus 2y square minus 2y plus 40. Either this is greater than 0 or y square plus y minus 20 is greater than equal to 0. This gives you this. I'm taking 2 common and dividing both the sides by 2. Okay. So now you want to have, let's splitting the middle term. You want to find 2 such numbers. The sum should be plus 1 and the product should be minus 20. Of course, they are 5 and 4. So the two factors are y plus 5 and y minus 4 is greater than equal to 0. That means y belongs to minus 5 comma 4. Let's check minus 5 comma 4. This is option A. Hope you understood this. Then let's move to the next question. Question number 12, the equation whose roots are squares of the roots of this equation is. So let's say this is fx is given to you as x raised to power 4 minus 2x cube plus 6x minus 21 is equal to 0. Now the required equation where roots are square of the roots of fx is given by f of root of x is equal to 0. So that means using this equation, now the required equation will be root of x whole square minus 2 into root of x whole cube plus 6 root of x minus 21 is equal to 0, which makes it x, sorry, here was raised to power 4 x square minus 2 x root x plus this minus this is equal to 0, which makes it x squared minus 21 is equal to 2x root x minus 6 root x, or x squared minus 21. I'll take this common. So you have this. Okay, let's do the squaring the both sides. I want to remove the root now. So if I'm squaring both the sides, this will become x raised to power 4 plus 441 minus 42x is equal to 4x into, I'll open this one also, a square plus 9 minus 6x. Okay. So this is equal to x raised to power 4 minus 4x cube minus 42x minus 36x plus 24x square plus 441 is equal to 0, which makes the equation as x raised to power 4 minus 4x cube and wait, this is minus 36x and minus 42. The students, I forgot to put a square over here. Here was x square, right? So minus 42x square plus 24x square will give you minus 18x square minus 36x plus 441 is equal to 0. So this is the required equation of the line. Let's check with the options. You have option A as the answer. Hope you understood this. Then let's move to the next question, number 13. If alpha, beta, gamma are the roots of this equation, then 1 plus alpha upon 1 minus alpha plus 1 plus beta upon 1 minus beta plus 1 upon 1 plus gamma upon 1 minus gamma is equal to. So the equation is x cube minus x plus 1 is equal to 0. We have to find out a polynomial whose roots are this. We have to find a polynomial with roots these three: 1 plus alpha upon 1 minus alpha, 1 plus beta upon 1 minus beta, 1 plus gamma upon 1 minus gamma. So let's say y is equal to 1 plus x upon 1 minus x, which makes, let's make x the subject of formula. So you can, solving this, you will get x is equal to y minus 1 upon y plus 1. See, if you will solve this equation, you will ultimately get this one. Now substituting this value in the given equation. Substituting x in equation 1. If I'm taking this as equation 1. Now this equation will become y minus 1 upon y plus 1 whole cube minus y minus 1 upon y plus 1 is equal to 0. So this will be y minus 1 whole cube minus y minus 1. Yeah, y minus 1 into y plus 1 whole square plus y plus 1 whole cube is equal to 0. This will be y cube minus 1. So a cube minus b cube plus 3y minus 3y square. And on solving this, you have minus y square minus 1, because I'm saying this. See, y minus 1 into y plus 1 into y plus 1. So I'm solving these two first. So this is y square minus 1 into y plus 1. Question number 13, if alpha, beta, gamma are the roots of this cubic polynomial, then 1 plus alpha upon 1 minus alpha plus 1 plus beta upon 1 minus beta plus 1 plus gamma upon 1 minus gamma is. So now you are given that alpha, beta, first thing you're given that this is the equation x cube minus x plus 1 is equal to 0. Here, alpha, beta, gamma are the roots. We have to find out these three values. So we need to find a polynomial whose roots are this 1 plus beta upon 1 minus beta, 1 plus gamma upon 1 minus gamma. Okay, so that type of equation will be, let y is equal to 1 plus x upon 1 minus x. So let's solve it. You can get y into this is equal to this, or y minus xy is equal to 1 plus x. I'll take x over here. So x minus xy is equal to 1 minus y. Yeah, that's it. I'll take, sorry, x is minus x. I'll take common 1 minus 1 plus y is equal to this, or x will be equal to y minus 1 upon y plus 1. Now, substituting this value of y in this equation. Substituting two in one. So this will become y minus 1 upon y plus 1 cube minus y minus 1 upon y plus 1 is equal to 0. So let's find out the LCM. Taking the LCM and solving it further, you have y minus 1 whole cube minus y minus 1, y plus 1 whole square, y plus 1 cube is equal to 0. This is a cube minus b cube plus 3y minus 3y square minus. So I can write it like this, y minus 1 into y plus 1 into y plus 1, which will give you y square minus 1 into y plus 1. So this is y square minus 1 into y plus 1 plus first number cube, second number cube plus 3y plus 3y square is equal to 0. Okay, now this and this 1 will get cancelled. 3y square and 3y square will cancel. Let's solve it further. You have y cube minus 1. Sorry, not minus 1. We have already cancelled that. So y cube plus 3y minus y cube plus y square minus y minus 1 plus y cube plus 3y is equal to 0. So that makes 2y cube plus 6y minus y cube minus y square plus is equal to 0. That is equal to y cube minus y square plus 7y plus 1 is equal to 0. So this is the required equation, y cube minus y square plus 7y plus 1 is equal to 0. We have to find out 1 plus alpha upon 1 minus alpha plus 1 plus beta, 1 minus beta, 1 plus gamma upon 1 minus gamma. This is nothing but sum of roots, which is given by minus the coefficient of x square or y square divided by the coefficient of y cube. This is minus of minus 1 upon 1, that is equal to 1. So the answer to the question is 1, option A. Hope you understood that. Let's move to the next question. Question number 14, 36, 34, C5 plus summation R from 0 to 4, 38 minus R, C4 is equal to. Let's write it down. This whole expression, this is equal to 34 C5 plus summation 38 minus, first of all, R is equal to 0. That makes 38 C4. Then R is equal to 1, which makes 37 C4. Similarly, 36 C4. Then 35 C4. Ultimately, 34 C4. Okay. So now I'll concatenate these two ones. These two terms. Now this will become 34C5 plus 34C4 plus 35C4 plus 36C4, 37C4, 38C4. Now this is equal to 35C5. Why? NCR plus NCR plus 1 is equal to N plus 1 CR plus 1. Okay. So using this becomes 35C5 plus 35C4, 36C4, 37C4, and 38C4. Now, these two using the same identity, this will be 36C5, 36C4, 37C4 plus 38C4. Now, I'll concatenate them, add them. You'll have 37C5 plus 37C4 plus 38C4. Now let's add them. You have 38C5 plus 38C4, which will be equal to 39C5. So this is the answer to the question, 39C5. Let's check. Option D is the correct answer. Hope you understood this. Let's move to the next question, number 15. If 22 PR plus 1 ratio 20 PR plus 2 is equal to 11:52, then R is equal to. Okay, first thing, let's do, see, this is 22 PR plus 1 upon 20 PR plus 2 is equal to this. Let's do the cross multiplication. You have 52 multiply 22 PR plus 1 is equal to 11 into 20 PR plus 2. So that's 52 into 22 factorial upon 21 minus R factorial. See, 22 minus R minus 1, this becomes 21 minus R factorial. That's equal to 11 into 20 factorial upon 20 minus R minus 2. That's 18 minus R factorial. So that's equal to 52 into 22 into 21 whole divided by 21 minus R, 20 minus R, 19 minus R. That's equal to 18 into, this is equal to 20 factorial, and here is also 20 factorial upon 18 minus R factorial. Here was this again. So these are going to cancel. You'll be left with 52 into 22 into 21 upon 21 R, 20 minus R, 19 minus R is equal to 11. Okay, again, cross multiplication. You have 52 into, see, this will cancel at 2. Okay, so 52 into 2 into 21 is equal to 21 minus R, 20 minus R, and 19 minus R. So that means, see, I can again write it as, you can write them as 21 minus R, 20 minus R, and 19 minus R. That's equal to, so I'll split 52. You can write it as 52 into 2 into 21. So you can write them as 14 into 13 into 12. So 21. See what I'm doing over here. I'm trying to bring them equivalent to these. So 21 minus R into 20 minus R into 19 minus R. This can be written as 14 can be written as 20 minus 7, 21 minus 7. Similarly, 13 can be written as 20 minus 7 and 12 can be written as 20 minus 8. Sorry, this is 9. This should be 19 minus 8. Wait. 19 minus 7. Okay, what I try to do, I try to bring a common number over here, that is 7, so that R will be same, and you can have 21 minus R as 21 minus 7 is equivalent to 21 minus 7. 20 minus R is equivalent to 20 minus 7 again, and 19 minus R is equal to 19 minus 7, which simply gives you R is equal to 7. And this is what we needed to find in the question. What is the value of R? It's 7, option C. Hope you got that. Next is question number 16. The value of the numerically greatest term in this expansion when x is half and y is 1/3 is So you have to find out the greatest term in the expansion of the general one, 1 plus x raised to power n. The greatest term of this can be written as n plus 1 into mod of x upon 1 plus mod of x, or 2x plus 3y raised to power 11, that is equal to, see, this is 2 into 1 by 2 plus 3 into 1 by 3 whole raised to power 11, that is equal to 1, that's equal to 1 plus 1 raised to power 11, or that's 2 raised to power 11. Okay. Now, greatest term. Using this formula, greatest term is n was 11. So 11 plus 1 mod of x. X is given to you as, see, this was the value of x. That's 2x, which is 1. Whole divided by 1 plus mod of x. That's 1 plus mod of 1. This gives you 12 upon 2, or 6. So T6, you can write it as T5 plus 1. What is T5 plus 1? That's equal to 11. That is, see, this is equal to NC R minus 1. So this is this, sorry, R, because I'm taking R as 5. Okay. So this is equal to 11C5. That's equal to 11 factorial upon 5 into 6 factorial, which is 11 into 10 into 9 into 8 into 7 into 6 factorial upon 5 factorial can be written as 5 into 4 into 3 into 2 into 1 into 6 factorial. They will cancel out. 5, 2, this will cancel this. So 3 will be cancelled over here and 4 will cancel this. So you have 11 into 6 into 7, which will give you 462 as the answer. So you have option A as the answer to the question. Hope you got that. Next is question number 17. Question number 17, the coefficient of x raised to power 4 in the expansion of this expression is, the given expression is 1 minus x square plus x raised to power 3 whole raised to power 6 is. Now this can be written as 1 minus x square plus x cube, can be written as 1 minus x into 1 minus x square. And further, this can be written as 1 minus x into 1 minus x into 1 plus x, which makes it 1 minus x whole square into 1 plus x. So you have to find out the coefficient of x raised to power 4 in that. In the expansion of 1 minus x square plus x cube, this can be written as, this whole raised to power 6 can be written as 1 minus x square into 1 plus x whole raised to power 6, or this is equal to 1 minus x whole raised to power 12 into 1 plus x. Right. Now, in the expansion of 1 minus x whole raised to power 12, coefficients are of the form minus 1 into r 12c r, and in the expansion of 1 plus x whole raised to power 6, there was 6 over here. So in this, in its expansion, the coefficients are of the form 6CR. So these are the coefficients in both the terms. Now you have to find out the coefficient of x raised to power 4. Coefficient of x raised to power 4 in the expansion of 1 minus x square plus x cube whole raised to power 6 is 12C0 into 6C4 minus 12C1 into 6C3, 12C 2 6c2 minus 12c3 into 6c1 plus 12c4 into 6c0. That's equal to 1 into 6c4 is 6 factorial divided by 4 factorial multiplied by 2 factorial. That's equal to 6 multiplied by 4 upon 2 minus 12 into 6 multiply 5 multiply 4 divided by 3 multiply 2, and that's equal to 12 into 11 upon 2 factorial, and the 6c2 is 6 into 5 into divided by 2 minus 12 into 6c1 is 6 only, and that's 12c, sorry, this is 12c3. So 12c3 is given by 12 into 11 into 10 whole divided by 3 into 2 multiply by 6 plus 12 multiply 11 multiply 10 multiply 9 whole divided by 4, 3, 2, 1 multiply 1. So this is going to give me 15 minus 240, and you have 3 over here. This is going to give you plus 990. 6 will cut, and this will give you minus 1320. 4 3s are 12, and this will cut at 5. So you will have plus 495. On solving this whole, you will get minus 60 as the answer to the question. So you have option D as the correct answer. Hope you understood. Let's move to the next question then. Question number 18. The sum of the coefficients in the expansion of 1 plus x by 2 whole raised to power 12 is. So very easy question actually. Sum of a coefficient in the expansion of 1 plus x by 2 whole raised to power 12 is equal to 1 plus 1 by 2 whole raised to power 12. You have to put variable x is equal to 1 over here. So this gives you 3 by 2 whole raised to power 12. Because this whole thing, because sum of coefficients in the expansion of 1 plus x whole raised to power n is given by 2n when you put this variable x is equal to 1. So you have option C as the answer. Hope you understood this. Next is question number 19. For any quadratic polynomial fx, it is true that fx is equal to fa plus f dash a into xa plus second derivative of f of the function at a divided by 2 factorial multiply x minus a whole square, where a is any real number. If 3x square plus 4x plus 7 upon x minus 2 whole cube is equal to this whole expression, and gx is equal to 3x squared plus 4x plus 7, then a plus b plus c is equal to. Okay, so I'll pick up this one. First of all, you are given the equation as 3x square plus 4x plus 7 whole divided by x minus 2 whole cube is a upon x minus 2 cube, b upon x minus 2 square, and c upon this. Let's take the LCM on both the sides, and cancelling the denominators, you will get 3x square plus 4x plus 7 is equal to a plus b into x minus 2 plus c into x minus 2 whole square. So now here you are given, first is fx is equal to f of a plus the first derivative of the function at a multiply x minus a plus the second divided by 2 this. And also you are given that gx is 3x square plus 4x plus 7. Right. So now let's compare these two equations. So that means if I'm say gx is equal to this function. So if I'm comparing both of them, these two equations, you get the value of a as 2. See here, a is 2. And that means a is equal to which was equal to f of a, that is equal to f of 2. B is equal to the first derivative. Sorry, this is not f, g. This is g of a, and so sorry, a is equal to g of a, that is g of 2. Similarly, b is equal to the first derivative, that means g dash 2, and c is equal to the second derivative, that is this. Right now, you have to find the value of a plus b plus c, which is nothing but g of a, which is g of 2 plus g dash 2 plus the second derivative at 2 divided by 2. Factorial it is. Right, so this is the answer to the question. We have option C as the answer. Hope you understood. Next is question number 20. So cot pi by 16 multiply cot 2 pi by 16 multiply 3 cot 3 pi by 16, cot 4 pi by 16, 5 pi by 16, 6 pi by 16, and 7 pi by 16. You have to find out the product of the cotangent of all these angles. Trigonometry problem. Let's go. Easy one. So first of all, I'll make pairs like this. So let's make the pair. You can write it as cot pi by 16 multiply cot 7 pi by 16 whole multiplied by cot 2 pi by 16 multiply cot 6 pi by 16 cot 3 pi by 16 multiply cot 5 pi by 16, and I will leave 4 pi by 16 as such. Okay, now cot 7 pi by 16 can be written as cot pi by 16 multiply cot pi by 2 minus pi by 16 multiply cotangent 2 pi by 16. Cot 6 pi by 16 can be written as cot pi by 2 minus 2 pi by 16 multiply cotangent 3 pi by 16 multiply cot pi by 2 minus 3 pi by 16 multiply cot 4 pi by 16. Now you know cos pi by 2 minus pi by 16 can be written as, I'm using the trigonometric ratio of the complementary angles. This can be written as tangent of pi by 16 multiply cotangent of 2 pi by 16 multiply tangent of 2 pi by 16 multiply cotangent of 3 pi by 16 multiply tangent of 3 pi by 16, and this whole is multiplied by cotangent of 4 pi by 16, which is actually pi by 4 only. Okay, so now these will cancel. All right, you are left with the cotangent of pi by 4, that is equal to 1. So you got the answer to the question as 1. Option B is the correct answer. Hope you got that. Next is question number 21. Let ACB be a right angle triangle at C. AB is 29, BC is 21 units, ABC is theta. Then you have to find out this. Okay. So you are given that this is a right angle triangle at C. So this is, let it be A and B like this. You are given AB is 29, ABC is theta, and BC is 21 units. All right. Okay. So you have to find out cos square theta minus sine square theta. First of all, let's find out AC. I'm using the Pythagoras theorem over here. AC will be given by 29 square minus 21 square by Pythagoras theorem. Right. So 29 square minus 21 square. What is 29 square equal to? That's so this is equal to 148 minus 441. That's giving you 400. So that's 20. AC comes out to be 20 units. So what is cos theta? That's based upon hypotenuse. So that is 21 upon 29. And sine theta is perpendicular upon hypotenuse. So 20 upon 29. Cos square theta minus sine square theta, which is 21 square this minus 20 upon 29 square. 29 square was 841. This is 441 minus 400, which gives you 41 upon 841. That's it. Option B is the correct answer. Hope you understood. Next is question number 22. 1 minus cos 2 theta plus sine 2 theta. Okay, upon 1 plus cos theta plus sine 2 theta is equal to. Right. So you can write down 1, 1 minus cos 2 theta is 2 sine square theta, and 1 plus cos 2 theta is equal to 2 cos square theta. So I will write it down. 1, 2 sine square theta, and sine 2 theta is 2 sine theta cos theta whole divided by 2 cos square theta plus 2 sine theta cos theta. I'm taking 2 sine theta common from the numerator. I'll be left with sine theta plus cos theta divided by 2 cos theta. Here will be cos theta plus sine theta. They will cancel and you have very easy tangent theta, the answer. Option C. Hope you got that as well. Let's move to the next question, number 22. Let y is equal to 4 sine square theta minus cos 2 theta if L and M are minimum and the maximum values of y respectively. Then which of the following is true? Right, you are given y is equal to 4 sine square theta minus cos 2 theta. I'll write down cos 2 theta as 1 minus 2 sine square theta, right? So what does y become? It becomes 6 sine square theta minus 1. Now you know one thing, sine square theta, it lies between 0 and 1, right? So that means this term, 6 sine square theta, will lie between 0 and 6. And if I'm subtracting 1 on both sides, minus 1 less than equal to 6 sine square theta minus 1 less than equal to 5. Or you can write it as minus 1 is less than y is less than equal to 5. Now, for the maximum value of y, what is the maximum value of y? It's 5. And the minimum is minus 1. Right. The maximum one was denoted, m is the maximum, L is the minimum. So this is equal to L and that is equal to M. Okay, so now if I take the product of both of them, I have minus 5. Divide M by L, I again get minus 5. So if I pick up the first option, Lm, which was minus 5, is equal to M upon L, which is again equal to minus 5. This is true. So option A is the correct answer. I got my first option correct, so no need to go with the rest of the options as well. Okay, so this is the answer to the question. Let's move to the next one. Question number 24, if cos theta is equal to minus 1 by 2 and tangent of theta is equal to 1, then the general value of theta is equal to what? You're given cos theta is minus 1 by root 2, which is equal to cos pi by 4, minus cos pi by 4, right? And you're given tangent of theta is equal to 1. That means this is equal to tangent of pi by 4. Now cos theta can be written as, see, this is minus cos pi by 4, so it can be written as cos pi plus pi by 4, because in the third quadrant, cosine is negative. Third quadrant, cosine is negative and tangent is positive. So that means the theta is going to theta is in the third, lying in the third quadrant. Okay. So that means theta also can be written, tangent of theta can also be written as tangent of pi plus pi by 4. Hence the general value of theta will be 2n plus 1 pi plus pi by 4, where n is equal to 0, 1, 2, 3, and so on. That's it. So following that, option B is the correct answer. Hope you got this. Next is question number 25. If sine inverse x is less than cos inverse x, then which of the following is true? You're given sine inverse x is less than cos inverse x, or sine inverse x is less than pi by 2 minus, this can be written as pi by 2 minus sine inverse x. I'll take this sign on the left hand side. So 2 sine inverse x is less than pi by 2, or sine inverse x is less than pi by 4. Here I can write down sine is less than, x is less than sine pi by 4. So what is sine pi by 4? That's 1 by root 2. That means x is less than 1 by root 2. Let's name this as 1. Now for sine inverse x, domain is minus 1 less than equal to x less than equal to 1. Let's name this as number 2. So from both of these equations, what we get, minus 1 is less than equal to x is less than 1 by root 2. That's it. So we have this answer. Let's check with the options now. Option A is the correct answer. Hope you understood. Next is question number 26. Cot h inverse 2 plus cos h inverse minus 2 root 2 is equal to what? Okay, so first general one, cot h inverse x, it is given by half log x plus 1 divided by x minus 1, where x is less than minus 1 or greater than 1. Also, cosec h inverse x is log 1 upon x plus root of this plus 1, where x is not equal to, this is the root, where x is not equal to 0. So simple as that. We have to find out. Let's fill in the values. Cot h inverse 2 plus cosecant h inverse 2 is equal to half log 1 by 2 plus 1, 1 by 2 minus 1 plus log of, sorry, this is this. Okay. So this is given by minus 2 upon root 2 plus root of 1 upon x square. So this is equal to 1 upon 4 into 2, that is equal to 8 plus 1, right? That is equal to half, here I forgot to write down the log. So half log, this is equal to 3 by 2 upon minus 1 by 2 plus log of minus 1 upon this plus root of 9 upon 8. That's going to give you half log of 3 plus log of minus 1 upon 2 root 2 plus 3 upon 2 root 2. This will be 2 root 2 over here 2, and this is log of 3 raised to power 1 by 2. That is equal to log of root 3 plus, these will cancel, log of mod 1 by root 2. right? So this will give you log of root 3 into 1 by root 2, which is this. That's it. So log root of 3 by 2 is the correct answer, option A. Hope you understood this. Next is question number 27. In a triangle ABC, B is pi by 4, C is pi by 3. If the area of the triangle is this, then what is the value of A? Okay, you are given a triangle. That would be A, B, which is pi by 4, and C is pi by 3. So this is ABC. Angle A is equal to pi minus pi by 4 minus pi by 3, which gives you 12 minus 3 pi minus 4 pi upon 12. That 12 pi, sorry. And this is 5 pi by 12. That's the value of angle A. Now, by the sine rule, you have A upon sine A is equal to B upon sine B is equal to C upon sine C, which gives you B is equal to A sine B upon sine A. Also, you know one thing, that the area of the triangle is given by half AB into sine C. So this can be written as half into A into sine B into sine C whole divided by sine A. And this area is given to you as 54 plus 18 root 3. So 54 plus 18 root 3 is equal to half of A square into sine B, which is sine B was sine pi by 4 sine pi by 3 upon sine 5 pi by 12. So that's equal to 54 plus 18 root 3 is equal to half into. So this is A square, sine pi by 4 is 1 by root 2, sine pi by 3 is root 3 by 2, whole divided by sine 5 pi by 12. Sine pi by 5 pi by 12, I have to find out the value of it. Sine 5 pi by 12 can be written as sine pi by 4 plus pi by 6, which is equal to sine A plus B, which is sine A, cos B plus cos A sine B. Sine pi by 4, 1 by root 2, multiply cos pi by 6 root 3 by 2 plus cos pi by 4 1 by root 2 and sine pi by 6 is 1 by 2. This is going to give me root 3 upon 2 root 2 plus 1 upon 2 root 2, that is root 3 plus 1 upon 2 root 2. Okay, this is the value. I'll fill this value over here. So this is root 3 plus 1 whole divided by 2 root 2. This is half into A square root 3 upon 2 root 2 divided by root 3 plus 1 upon 2 root 2. So this will cancel, both of them will cancel each other. And you are having 54 plus 18 root 3 over here. Okay, this is 2 into 54 plus 18 root 3 is equal to A square root 3 upon root 3 plus 1. So this is 24 into 54 plus 18 root 3 into root 3 plus 1 upon root 3. That is equal to A square. Okay, so let's 2 into 18 root 3, I'll take common. I'll be left with root 3 plus 1 upon root 3 into root 3 plus 1 is equal to A square. So this is 36 into root 3 plus 1 whole square is equal to A. So A will be equal to 6 root 3 plus 1. That's it. So you have this answer. A is equal to 6 root 3 plus 1, option D. Hope you understood. Next is question number 28. If A, B, C are sides of the triangle ABC and extra die R1, R2, R3 are respectively X radii. Question number 27. In a triangle ABC, B is pi by 4, C is pi by 3. If the area of the triangle is 54 plus 18 root 3 square units, then A is equal to. Let's make the triangle. You are given the triangle ABC. This is A, B is pi by 4, and C is pi by 3. So according to that, what will be A? It will be pi minus pi by 4 minus pi by 3, which is 12 pi minus 3 pi minus 4 pi upon 12. That is 5 pi by 12. So you got A as 5 pi by 12. Now your given area of the triangle is this. First of all, by the sine rule, you have pi sine rule. You have A upon sine A is equal to B upon sine B is equal to C upon sine C. From here, I'm just picking up two like A and B. B can be written as A into sine B upon sine A, right? Now, area of the triangle is given by half into AB into sine C. So this is 54 plus 18 root 3 is equal to half into A. B was equal to A sine B upon sine A into sine C. Okay, so I'll multiply this with 2. 54 plus 18 root 3 is equal to A square sine pi by 4 pi by 3 sine 5 pi by 12. That's sine pi by 4 is equal to 1 by root 2 pi by 3. It's this. And I have to find out the value of sine pi by 5 pi by 12. Let's go with this first. Sine 5 pi by 12 can be written as sine pi by 4 plus pi by 6. This is something called sine A plus sine B, which is sine A cos B plus cos A sine B. Sine pi by 4 is 1 by root 2. Cos pi by 6 is root 3 by 2 plus 1 by root 2 multiplied by sine pi by 6 is 1 by 2. That gives you LCM 2 by root 2 root 3 plus 1. So the value of sine 5 pi by 12 is equal to root 3 plus 1 whole divided by 2 root 2. Okay. All right. So this is 2 into 54 plus 18 root 3. Okay, one thing I'll do, I'll take 18 root 3 common. So this inside I'll be left with root 3 plus 1. Okay, this is equal to A square into root 3 whole divided by 2 root 2 whole divided by root 3 plus 1 upon 2 root 2. They will cancel out and you have 36 root 3 into root 3 plus 1 is equal to root 3 upon root 3 plus 1 into A square. Let's do the cross multiplication. So 36 root 3 into root 3 plus 1 square divided by root 3 is equal to A square. You will be left with 6 root 3 plus 1 is equal to A. So the value of A is root 3, 6 root 3 plus 1, which is option D. Hope you understood that. Let's move to the next question, number 28. If ABC are sides of a triangle ABC and x radii R1, R2, R3 are 12, 6, and 4 respectively, then you have to find out this value. Okay, R1 is 12, R2 is 6, and R3 is 4. 1 upon R is given by 1 upon R1 plus 1 upon R2 plus 1 upon R3. So 1 upon 12 plus 1 upon 6 plus 1 upon 4. The LCM is 24 now. So this is 2 plus 4 plus 6, that is 12 by 24 or 1 by 2. So the value of R comes out to be 2. Now, what is A square? It's R1 minus R into R2 plus R3. So that is equal to 12 minus 2 into 6 plus 4. That gives you 100. Okay. So what is A? This is A square. A becomes equal to 10. What is B square? R2 minus R into R1 plus R3, which is 6 minus 2. 12 plus 4, that is equal to 64, or B is equal to 8. Now, C square is R3 minus R, R1 plus R2, which is 4 minus 2, 12 plus 6, that is 36, or C is equal to 8. What we needed to find out in the question was A plus 2B plus 3C. What was A? 10 plus 2 into 8 plus 3 into 6. So 10 plus 16 plus 18, that is equal to 44. So the answer to the question is option B. Hope you understood. Next is question number 29. In a triangle ABC, if A ratio B ratio C is equal to 4:5:6, and you have to find out this value. Okay. So one thing, R1 plus R2 plus R3 minus R is equal to 4 capital R. You know this thing. So R1 plus R2 plus R3 is equal to 4, number 1. Now let A upon 4 is equal to B upon 5 is equal to C upon 6 is equal to some K, right? Then A can be written as 4K, B can be written as 5K, and C can be written as 6K. You know, S is the semi-perimeter, which is A plus B plus C upon 2. That makes 4K plus 5K plus 6K upon 2, or 15K upon 2. Now the area of the triangle is given by root of S into S minus A, S minus B, and S minus C. So this is 15K by 12, 15K by 12 minus 4K, 15K by 12 minus 5K minus 6K. That's equal to area of the triangle. So this is root of 15K by 2, 7K by 2, 5K by 2, and 3K by 2. So I'll take the K square upon 2 square, which is 4 outside, and inside will be left with 15 multiply 7 multiply 5 multiply 3, which is 15K square upon 4 into root 7. Now, R is given by delta upon S, which is 15K square into root 7 upon 4, divided by, so I'll reciprocate it. So this is 2 upon 15K. This will cancel. This will cancel. and you will have root 7 upon 2k. Okay, now r is equal to delta upon s, which we found out the value of root 7k upon 2. Capital R is equal to ABC upon 4 delta. So this is 4k, 5k, 6k upon 4 into 15k square into root 7 upon 4. So this will cancel out, and this will cancel at 3, 2. So that is equal to 8. Also the k's will cancel this way. So this is 8k upon root 7. Okay. Now 1 upon 4 R1 plus R2 plus R3 is equal to 4R plus small r upon 4R from this equation. 1. Right. So this is 1 plus r upon 4R, or this is equal to 1 plus r. We just calculated, it was 8k upon root 7 divided by 4 into capital R is, this is capital R, and the small r was this. Let's write down first. Small r was root 7k upon 2, and the capital R was 8k upon root 7. So this is equal to 1 plus root 7 upon 2k upon 4 into 8k upon root 7. So this is equal to 1 plus root 7 upon 2k multiply root 7 upon 4 into 8k. K's will cancel, and you will have 1 plus 7 upon 64, which will give you 71 upon 64. So this is the answer to our question. 71 upon 64 is option A. Hope you understood this. Let's move to the next question then. Students, there is a small correction in the sum over here. Actually, this is 4R plus R. I just missed this thing. This is R1. From here, you can say R1 plus R2 plus R3 is equal to 4R plus R. That's it. Now, next is question number 30. In the triangle ABC, with the usual notation, if A is equal to 12, B is 16, C is 20, then the ratio of x radii of the triangle opposite to the angles in the order C, B, A is. So in the question, you are given that A is 12, B is 16, C is 20. So what is the value of A? You know that is equal to A plus B plus C upon 2, which is equal to 12 plus 16 plus 20 upon 2, or that is equal to 48 upon 2, which comes out to be 24. Now the area of the triangle is root of S into S minus A, S minus B, S minus C, this whole under the root, which is equal to root of 24, 24 minus 12, 16, and 20. Right. So this is equal to 24 into 12 into 8 into 4. Let's take the root of it. And you will find out it will come out to be 96. Now what is R1? You know that is equal to delta upon S minus A, which is 96 upon 24 minus 12, 96 upon 12, or this is equal to 8. R2 is equal to delta upon S minus B, 96 upon 24 minus 16, that is 96 upon 8 or 12. R3 delta upon S minus C, 96 upon 24 minus 20, so 96 upon this, or this is equal to 24. Now the ratio of external radii of the triangle, or ratio of external radii of the triangle opposite to the angles in the order angle C, angle B, angle A is 24 is to 12 is to 8. This is equal to 6 is to 3 is to 2. So that's it. You have the answer as option B. Hope you understood this. Let's move to the next question then. Question number 31. Students, before moving to this question, is a quick reminder to visit our website www.examsnet.com for a better preparation of your exams. A very best of luck. There you can find multiple entrance exam question papers of the similar type and also their PDFs and detailed solutions. You can also download our app. The link is available in the description box. So now let's read the question. It says, if the vectors this and this are collinear, then lambda minus mu is equal to. Okay, so if these two vectors are collinears, then their respective coefficients are in the same ratio, which means minus 3 upon mu is equal to 4 upon 8 is equal to lambda upon 6. Minus 3 upon mu will be equal to 1 by 2, and this is equal to lambda upon 6. Or you can write them separately also. And lambda by 6 is also equal to 1 by 2. So from here, mu is equal to minus 6 and lambda is equal to 3. That's it. Lambda minus mu is equal to 3 minus of minus 6. That gives you 9. A pretty easy question. Option D is the correct answer. Hope you understood this. Then let's move to the next question. Question number 32. The angle between these two vectors is, you have to find out the angle between these two vectors. Okay. So let the angle be theta. Cos theta will be given by, see, over here there is no I. So I can write it as 0 into I plus minus 0 I minus 3j plus 2k and I minus 0 into j minus 2k. So cos theta is 0 into 1 plus minus 3 into 0 plus 2 into minus 2 whole divided by the root of 0 square plus minus 3 square plus 2 square multiplied by, wait, this root is like this. So 0 square plus minus 3 square plus 2 square multiplied by 1 square plus 0 square plus minus 2 square. That gives you minus 4 upon root of 9 plus 4, that is equal to 13 multiplied by root of 5, which is minus 4 root of 65. So theta is equal to cos inverse minus 4 upon root of 65, which is option B. Hope you understood this. Let's move to the next question then. Question number 33. Three vectors A, B, C satisfy this equation. If magnitude of A is 3, B is 4, C is 2, then A dot B plus B dot C vector plus C dot A vector plus this is equal to what? So here you are given first the sum of the three vectors is equal to 0, which can also be written as A plus B plus C is equal to 0, because you have A square. In case of vectors, that's A into A. So squaring the both sides, you get A plus B plus C is equal to 0, which gives you A square, magnitude of A square plus B square plus magnitude of C square plus 2, A dot B plus B dot C, C dot A is equal to 0. This gives you 3 square, that is 9 plus 16 plus 4 plus 2 into A dot B plus B dot C plus C dot A is equal to 0. So you get A dot B, B dot C, C dot A is equal to minus 29 upon 2. Now, you have to find out the value of this particular expression. Question number 33. Three vectors A, B, C satisfy this equation. If magnitude of A is 3, B is 4, and C is 2, then you have to find out the value of this given expression. Okay, in the sum of the three vectors is equal to 0, which means A plus B plus C is equal to 0. Because you have, see, A square, that is equal to A dot A. This is a dot product of both the vectors. So this A plus B plus C is also equal to 0, which further you can say squaring both sides. A plus B plus C whole square is equal to 0. Open it up. Magnitude of A square plus B square plus magnitude of C vector square plus 2 into dot product of A dot B, B dot C, C dot A is equal to 0. A square, that is 3 square 9 plus 4 square 16 plus 2 square 4 plus 2 into the dot product like this. So from here you can say this A dot B plus B dot C plus C dot A is minus 29 upon 2. Now you have to find out this particular expression. Let's write it. To find A dot B, B dot C, C dot A plus 2 magnitude of A plus B plus C, that is equal to, see, this was equal to minus 29 upon 2 plus 2. A was 3, B was 4, and this is 2. That is minus 29 upon 2 plus, this is 9, 18. So this gives you minus 29 plus 36 upon 2. That is equal to 7 upon 2. So the answer to the question is 7 upon 2. Option B is the correct answer. Hope you understood. Next is question number 34. So you are given this vector, this A plus 2B minus C multiplied by this whole series is equal to. Let's write them down. You have A plus 2B minus C. I'll write it without the vectors normally. So A plus 2B minus C, the dot product with A minus B, cross product A minus B minus C is equal to A plus 2B minus C, dot product of, now A dot A cross A, sorry, A cross A minus A cross B minus A cross C minus B cross A plus B cross B, B cross C. This is further A plus 2B minus C, 0. Cross product of both of them is 0. So this is 0 minus A cross B minus A cross C, and minus B cross A can be written as plus A cross B. Okay. So plus, this is 0, B cross C. Okay. That is A plus 2B minus C is minus A. See, these two will cancel out and you will have minus A cross C plus B cross C, which is A plus 2B minus C. Let's write it like this. Okay. So now let's find out the dot product. Here was the dot product of all of them. So this is equal to A dot B cross C plus C dot wait, A dot B cross C minus A cross C plus 2B, B cross C minus 2B, A cross C minus C, B cross C. Here's the dot product everywhere, and plus C, A cross C, which is equal to A dot B cross C plus 2B C cross A. Okay. Question number 34, the dot product of these two vectors is equal to what? So this is given to be a plus 2b minus c dot product with a minus b cross a minus b minus c. So this is equal to a plus 2b minus c dot product with, let's open it up. You will have a cross a minus a cross b minus a cross c minus b cross a plus b cross b plus b cross c. That's equal to a plus 2b minus c, right? And the cross product of a and a, this is 0 minus a cross b minus a cross c. This can be written as plus a cross b plus 0 plus b cross c. Now this is equal to a plus 2b minus c. First of all, these two will cancel out. And you will have b plus c minus a cross c. Let's do the dot product now. Open it up. You will have a dot b cross c minus a dot a cross c plus 2b dot b cross c minus 2b dot a cross c minus c dot b cross c plus 2b a cross c, right? Okay, so this will be equal to a dot b cross c plus 2b dot c cross a. Now this can be written as a bc plus 2 bca, which is abc plus 2 abc, that is 3 abc. So this is answer to the question. Option C is the correct answer. Hope you understood this. Then let's move to the next question, number 35. A is given by I plus j plus k and C is given by j minus k. These are the two vectors. Then you have to find the vector B, which is satisfying these two equations. Okay, so here A vector is I plus j plus k and C vector is j minus k. Now we are given more. A cross B is equal to C vector. Also A dot B is equal to 3. Correct. Okay, so next is I'll cross product both sides by A. So this can be written like this. Further, this is equal to A dot B A plus minus, sorry. A dot A B is equal to A cross C. Now this is equal to 3. So 3A minus mod of A square B is equal to A cross C. Let's name this as 1. Now, first of all, I'll find out mod of A. What is mod of A? A was equal to, that is equal to root of, mod of A is equal to root of this. 1 square plus 1 square plus 1 square. That is equal to root of 3. So mod of A is equal to, sorry, mod of A square is equal to 3. Now let's find out A cross C. What is that equal to? See, for that, I'll use the matrix method. I, J, K. This is 1, 1, 1. And further you have 0, 1 and minus 1. So this is equal to minus 1, I cap, minus J, minus 1, minus 0 plus K, 1 minus 0, which is minus 2I plus J plus K. So now I'll fill both of these things in equation 1, putting them in equation 1. You will get 3I plus J plus K minus 3B is equal to minus 2I plus J plus K, which gives you 3I plus 3J plus 3K plus 2I minus J minus K is equal to 3B. Or B will be equal to, this is 5 by 3 I cap plus 2 by 3 J cap plus 2 by 3 k cap. This is the answer to the question. And you have option C as the correct answer. Hope you understood this. Next is question number 36. Let A be this vector, B be this vector, C be this, and D be this vector. If A cross B cross C is perpendicular to D, then X is equal to. So you are given here A cross B cross C is equal to, not given actually, this is equal to A dot C B, B dot C A, which means 2I minus 3J plus K dot I minus J I plus 2J minus 3K minus I plus 2J minus 3K dot I minus J 2I minus 3J plus K, which is equal to 5I plus 2J minus 3K plus 2I minus 3J plus K, which is 7I plus 7J minus 14K. Now you are given that this is perpendicular to D. Given A cross B cross C is perpendicular to D, which means A cross B cross C dot product with D is equal to 0. And we just solved this is equal to 7I plus 7J minus 14K dot product with, let's say this, see, D is given to you as this, I plus J plus XK. I plus J plus XK is equal to 0. This is the dot product. So this is 7 into 1 plus 7 into 1 minus 14 into x is equal to 0. 14 minus 14, x is equal to 0, which gives you x is equal to 1. That is option D is the correct answer. Hope you got that. Next is question number 37. If 10 is the mean of this data, then the mean deviation of this data about its mean is. Okay. So first thing you are given that the mean of the data, if I'm representing this with x bar, this is 10. And you know, this is equal to sum of the observations divided by number of the observations. So 2 plus 3 plus 5 plus 18 plus 17 plus 15, 13, x, 9, and 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This whole is divided by 10. And this gives you 10. Which let's add all of them. So this is 5 plus 5, 10, 28, and 32. 16, this is 29. So a 9 over here. Then you are having 4, 7. 89. Okay. I think it's 5, 10. Yeah, just check the sum is 89, of course, upon 10. So this is equal to plus x. This is equal to 100, which gives you x value as 11. Now, deviation from the mean is deviation from the mean is this. We get, see, the first term was 2 and the mean was 10. So this is 8. The second is 3 and the mean is 10. So 10 minus 3, this is 7. Similarly, 5, 8, 7, 5, 3, 1, 1, 3. These are the mean deviations. Now, mean deviation about the mean deviation. This was the deviation and we have to find the mean deviation now. Mean deviation about the mean is equal to sigma xi minus x bar upon sigma, that is number of terms. Okay. And let's add them. That is 8 plus 7 plus 5 plus 8 plus 7 plus 5 plus 3 plus 1 plus 1 plus 3 whole divided by 10. That's equal to 4.8. Okay, so we have option B as the correct answer. Hope you got that. Next is question number 38. A, B, C are aiming to shoot a balloon. A will succeed 4 times. Out of 6 attempts, the chance of B to shoot the balloon is 3 out of 5. C is 2 out of 3. If 3 aim to shoot the balloon simultaneously, then the probability that at least 2 of them hit the balloon is. So I'll start with A, probability of A hitting the balloon. A hitting the balloon is 4 upon 6, which is 2 upon 3. Similarly, probability B hitting the balloon is given by 3 by 5. And C hitting the balloon is 2 by 3. Right. Now the probability of hitting the balloon by at least 2 of them. Probability of hitting the balloon by at least 2 of them, that is A, B, C, and at least 2 of them hit, is given by the probability that A hit, B hit, and C does not hit, plus the probability A hit, B does not hit, and C hits, plus the probability A does not hit, and B hits, and C hits, plus the probability that all of the 3 hit. Right? So now, the first one, this is equal to probability of A cross probability of B cross probability of C not hitting, plus probability A plus probability of B not hitting, plus probability of C hitting. Yes, plus next is probability A not hitting, plus probability B hitting, plus probability C hitting, plus probability A, probability B to hit, probability C to hit. Now you just have to fill in the values. Right. Probability of A, this was equal to 2 by 3 into 3 by 5 into 1 by 3. Sorry, there is cross over here. Sorry for this. Okay. Plus 2 by 3. See, probability, I'll discuss that also. Probability of A not to hit is equal to 1 minus 2 by 3, which is 1 by 3. Probability of B not to hit is 1 minus 3 by 5, which is equal to 2 by 5. And the probability of C not to hit is 1 minus 2 by 3, which is equal to 1 by 3 again. Okay. Now I'll fill in the values. So this is 2 by 3 into 2 by 5 into 2 by 3. Plus 1 by 3 into 3 by 5 into 2 by 3 plus 2 by 3 into 3 by 5 into 2 by 3. Now this makes 6 upon 45, 8 upon 45, 6 upon 45 and 12 upon 45, which is 32 upon 45. All right. So here we have option D as the answer. Hope you understood this. Let's move to the next question, number 39. So here says that omega is a complex cube root of unity, which when an unbiased die is thrown 3 times, if beta 1, beta 2, beta 3 are the numbers appeared on the die, then the probability that they satisfy this equation is, okay, first thing, the total number of ways of throwing an unbiased, total number of ways of throwing an unbiased coin 3 times is 216. Next, beta 1, beta 2, and beta 3. They satisfy the, okay. The question was, if beta 1, beta 2, beta 3 are the numbers appeared on the die, then the probability that they satisfy this equation. All right, so they satisfy the equation omega raised to power beta 1 plus omega raised to power beta 2 is equal to minus omega raised to power beta 3. Or you can write it as omega raised to power beta 1 plus omega raised to power beta 2 plus omega raised to power beta 3 is equal to 0. Then beta 1, beta 2, and beta 3 is a permutation of the numbers of the form 3k, 3k, 3n plus 1, 3n plus 2 from set 1, 2, 3, 4, 5, and 6. Thus, beta 1 and beta 2 and beta 3 can be chosen in 2 into 2 into 2 into 3 factorial ways, right? So the required probability is equal to 2 into 2 into 2 into 3 factorial upon 6 into 6 into 6, which was over here, is equal to, this will cancel at 3 into 3 into 3, and 1, 3 will be cancelling here. So you will be left with 2 factorial. So this gives you 2 upon 9. That's it. 2 upon 9 is the required answer. Option D. Hope you understood. Next is question number 40. If probability A upon B is 3 by 10 and probability B upon A is 4 by 5 and PA union B is K, PB, then 1 upon K is. So here you have probability A upon B, this is 3 by 10, and probability B upon A is 4 by 5. And you are given the third thing, probability A union B is this. Right? So from these two, you can say probability A intersection B is equal to 3 by 10. PB. Also, probability A intersection B is equal to 4 by 5 PA. So from both of them, these two are equal. That is 3 by 10 PB is equal to 4 by 5 PA, or PA upon PB is equal to 3 by 8. How we will get this? See, this is 4 by 5 multiplied 10 upon 3, which gives you question number 40. If PA upon B is this and PB upon A is this, and PA union B is KPB, then 1 upon K is equal to. You are given probability A upon B is 3 by 10 and probability B upon A is 4 by 5. Right? I can write down like PA intersection B is 3 by 10 PB, and here probability A intersection B is 4 by 5 PA. So both of them, they are equal, which makes 3 by 10 PB is equal to 4 by 5 of PA. So PA upon PB, this becomes 3 by 10 into 5 by 4. That makes it 3 by 8. Now, you are given that probability A union B is equal to KP B. That means K is equal to probability A union B upon probability of B. Now, A union B is PA plus PB minus A intersection B whole divided by PB. right? So this is equal to PA upon PB plus 1 minus PA upon B, right? This is equal to PA upon B. And this we just solved. This came out to be 3 by 8 plus 1 minus 3 by 10. Let's take the LCM. So I'll take the LCM. We'll have, let's say, 40. So 15 plus 40 minus 12. This is going to give me 43 upon 40. This is the value of K. You have to find out the value of 1 by K, which is 40 upon 43. So 40 upon 43 is option B. So this is the correct answer to the question. Hope you understood. Next is question number 41. If the probability that an individual will suffer a bad reaction from an injection is 0.001, then the probability that out of 2,000 individuals, exactly 3 individuals will suffer a bad reaction is. Here you are given that the probability of the event to happen is 0.001. That means and the number of events over here is 2,000. So what is you have to find out probability that out of 2,000 individuals, exactly 3 individuals suffer a bad reaction. So here, lambda is equal to n into p, which gives you lambda is equal to 2,000 into probability 0.001, which will give you the value as 2. Now the probability x is equal to x is e raised to power minus lambda raised to power x upon x factorial. So lambda is 2. We just calculated. This is e raised to power minus 2. 2 raised to power x, which is 3. You have to find out for 3 individuals upon 3 factorial. So this gives you 1 upon e square into 8 divided by 6, which will give you 4 by 3 e square. That's it. You have the answer as option A. Hope you understood. Next is question number 42. A fair coin is tossed 15 times. The probability that the tail will appear at least thrice. Okay. First of all, when you toss a coin, what is the probability of getting a tail? It's 1 by 2. Then the probability of getting a head. See, the probability, the question is for the tail. So this is P is 1 by 2. What will be the value of Q? That is getting a head. That will be 1 by 2 again. So the coin is tossed 15 times, which makes n is equal to 15. Now the question is probability that tail will appear at least thrice. So probability that the event will happen 3 or more than that. This is given by 1 minus p x is equal to 0, that no tail occurs, plus probability 1 tail occurs, plus probability 2 tails occur. So this is equal to 1 minus 15 because NC 0 plus 15C 1, 15C 2. Okay, so fine. This is multiplied by 1 upon 2 raised to power 15. So this is 1 minus 1 minus 15. And 15C2 is 15 into 14 upon 2, which is 15 into 7. That is 105. So plus 105 plus over here into this. So this is 1 minus 121 upon 2 raised to power 15. That's it. This is the answer to the question. Option B. Hope you got that. Next is question number 43. A rod of length 6 units slides with its end on the coordinate axis. The locus of the midpoint of the rod is. So you are given there is a rod of length 6. Let's say this is a rod. This is the coordinate axis. So here is the rod AB. The rod is of length 6 units. With its end on the coordinate axis, the locus of the midpoint of the rod is. So if I'm taking P to be the midpoint with the coordinates as HK, here I'm taking this point A as, let's take it as B, so 0B, and I'm taking this point as A. The coordinates are A, 0. So I'm writing the coordinates. Let the coordinates of A be A comma 0, B be 0 comma B, and P has the coordinates as H comma K. Now this is the midpoint of the rod AB. Now here H is equal to A plus 0 by 2. K is B by 2 similarly. So A becomes 2H and B becomes 2H. Sorry, 2K. B becomes 2K. Now by Pythagoras theorem, OA square, if I'm taking this as OA square plus OB square is equal to A square, which means A square plus B square is equal to 6 square, which is A was equal to 2H and B was equal to 2K. This is equal to 36, which makes X square plus K square is equal to 9. That's it. So locus of the midpoint is X square plus Y square is equal to 9, which is option A. So here we have option A as the correct answer. Hope you got that. Next is question number 44. The transformed equation of this curve when the origin is translated to this point is simple. Okay, so origin is translated to this point. In this case, I'll replace X with X minus 1 and Y with Y plus 2. Right. So simple. Let's frame the equation now. This one. You will have 2 into X minus 1 square plus Y plus 2 whole square minus 3 into X minus 1 plus 5 into Y plus 2 minus 8 is equal to 0. So 2x square plus 1 minus 2x plus y square plus 4 plus 4y minus 3x minus 3 plus 5y plus 10 minus 8 is equal to 0. 2x square plus 2 minus 4x plus y square plus 4 plus 4y minus 3x plus 3 plus 5y plus 10 minus 8 is equal to 0. So this equation will be now 2x square plus y square minus 7x plus 9y plus 11 is equal to 0. So this is the required equation. Option A is the correct answer. Hope you got that. Next is question number 45. The point on this line, which is equidistant from these 2 points is, okay, so first of all, let P be that point with XY coordinates. So you are given the equation 4x minus y minus 2 is equal to 0 and P is equidistant from A and B. That means PA is equal to PB or PA square is equal to PB square. This makes x plus 5. I'm using the distance formula over here. Y minus 6 square is equal to x minus 3 square, y minus 2 square, x square plus 25 plus 10x, y square plus 36 minus 12x is equal to x square plus 9 minus 6x, y square plus 4 minus 4y. They will cancel out and you'll be left with 16x minus 8y plus 48 is equal to 0 or 2x minus y plus 6 is equal to 0. So now let this be equation 2 and this was equation 1. Let's solve both of them simultaneously. Solving 1 and 2. The first equation 2x minus 4y plus 6 is equal to 0 and 4x minus y minus 2 is equal to 0 minus plus plus. This will cancel. Minus 2x plus 8 is equal to 0 or x is equal to 4. When x is equal to 4, here is, sorry, 4x minus y minus 2 is equal to 0. So 16 minus y minus this is equal to 0, which gives you the value of y as 14. So x is equal to 4 and y is equal to 14. This is the answer to the question. Let's check. You have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 46. The in-center of the triangle with these vertices is, vertices are quite clear. Let's frame them. Let's put them on the coordinate axis. So this is the point B. Let it be O. This is origin, right? So this is point O having the coordinate 0, 0. And this is, let it be A, coordinates 2, 0, and B coordinates 1, root 3. So now let's say OA is equal to 2. OB is root of 1 square plus root 3 square, which is 3, which gives you 2 again. OC is equal to, not OC, sorry, AB. AB is equal to 2 minus 1 square plus 0 minus of root 3 square, which is 3 again, which gives you 2 again. So you see one thing, OA is equal to OB is equal to AB. So therefore, this is an equilateral triangle, right? So if the equilateral triangle is there, the in center will be 0 plus 2 plus 1 upon 3 whole divided, comma, 0 plus 0 plus root 3 upon 3. So that's equal to 1 upon 1. Sorry, I'll write it again. 1, 1 upon root 3. That's it. So you have option D as the answer. Hope you got that. Next is question number 47, students. Before starting with this question, here's a quick reminder to visit our website www.examsnet.com to practice not only this, but similar type of multiple entrance exam question papers and crack your exams without any fail. You can also download our app. The link is available in the description box. Here we go with the question number 47. If P dash AB is the image of this point with respect to this line, then the length of perpendicular from that image point onto this line is equal to. Let's try to understand the whole situation using a diagram. So this is the point P, coordinates minus 1, 2, and this is the line. This is the line x minus 2y plus 3 is equal to 0. So this is falling, of course, perpendicularly, and this is forming the image P dash over here. And I don't know the coordinates. It's AB given to you. Okay. Fine. So let this be the point of intersection. Let's say this is the point R. Now, image of point P, that is minus 1, 2 with respect to x minus 2y plus 3 is equal to 0 is A plus 1 upon 1, B minus 2 upon minus 2 is equal to minus 2 minus 1 minus 4 plus 3 whole divided by 5. Now, why minus 2 over here? Because this distance has simply doubled. Okay. This plus this. So the distance has doubled. So there is a 2 over here. Hope you got this thing. So here you have A plus 1 is equal to B minus 2 upon minus 2. This is equal to minus 5 this, and this will give me minus 2 into minus 2 upon this. That is equal to 4 upon 5. Okay. So A's value is equal to 4 by 5 minus 1. This is minus 1 by 5. Similarly, B is equal to, actually, this is B minus 2 upon minus 2 is equal to 4 by 5, which gives you B is equal to minus 8 by 5 plus 2. That will give you 2 by 5. Okay. Now you got the values of A and B. So length, the coordinates become minus 1 by 5 and 2 by 5. So the length of perpendicular from P dash, which is given by minus 1 by 5, comma 2 by 5 on 2x plus y minus 7 is equal to 0 is minus 2 by 5. Minus 2 into 1 by 5 will give you minus 2 by 5. Plus 1 into 2 by 5 will give you 2 by 5 minus 7 whole divided by the root of 2 square plus 1 square, which is equal to 7 by root of 5. That's it. This is the answer to the question 7 by root 5, option C. Hope you got that. Next is question number 48. If the vertices of the triangle ABC are these three, then the equation of bisector of angle ABC is. Let's say this is the triangle ABC. One comma 7, minus 5, minus 1, and C is 7 comma 4. These are the three vertices, and you have to find out equation for the bisector of angle ABC. So let this be the bisector which is meeting AC in the point D. Let the coordinates, okay, I have to find out the equation for BD. First thing, by using the angle bisector theorem, you know AD upon DC is equal to AB upon BC by angle bisector theorem, right? So AB is equal to, what is AB equal to? You know the two coordinates. A is having the coordinates as 1 comma 7, B is having minus 5 minus 1. So AB is equal to root of minus, this will be 6 square, that is minus 5 minus 1 square plus minus 1 minus 7 square. That's going to give me 6 square, which is 36, and 8 square, 34, which is going to give me 10. So AB is equal to 10, and BC is equal to root of minus 5 minus 7, that is 12 square, minus 1 minus 4, which is equal to 5 square. So this is 144 plus 25, 169 or 30. So I got AB and BC values. Let's use this equation now. AD upon DC is equal to 10 upon 13. So that means D is dividing this line in the ratio of 10 is to 13. Using the section formula, I can find the coordinates of D. A had the coordinates as 1 comma 7. C had the coordinates as 7 comma 4. And this is dividing, D divides them in the ratio 10 is to 13. So coordinates of D, if I'm taking them to be XY, so the coordinates of D are equal to 10 into 7 plus 13 into 1 upon 10 plus 13. 10 multiply 4 plus 13 multiply 7 divided by this again. So this is equal to 83 upon 23, 131 upon 23. These are the coordinates of the D. My equation of D, you got the coordinates of D. So equation of D, BD. B had the coordinates as minus 5 minus 1. D had the coordinates as 83 upon 23, 131 upon 23. So equation, first of all, let's find the slope of BD. That is equal to 131 upon 23 plus 1 upon 83 upon 23 plus 5. So this gives you 131 plus 23 upon 23 whole divided by 83 plus 23 divided multiplied by 5, it's 115 whole divided by 23. So this is cancelling. You have 154 upon 198 as the slope of BD. What is the equation of BD? Y minus of minus 1 is y plus 1. Slope this. X minus of minus 5 will give you x plus 5. So this equation will be y plus 1 into 198 is 154 into 154 into x plus 5. So let's cancel them. They will cancel at 11 first. So this will be 18 and this will go at 14. Again, 9 and 7. So you have 9y plus 9 is equal to 7x plus 35 or 7x minus 9y plus 26 is equal to 0. This is the answer to the question. 7x minus 9y plus 26. Option A. So this is the correct answer to the question. Next is question number 49. Hope you understood the last question. The combined equation of two diameters of a circle which divide the circle in 4 sectors is this. The area of the bigger sector is 5 times the area of the smaller sector. Then A plus B mod divided by this whole expression is equal to. So first thing, you are given combined equation of two diameters of a circle which divide the circle in 4 sectors. Let's make the circle. So now it is said that the circle is being divided in 4 sectors. First, let A be the angle subtended by bigger sector on center. Then, if I'm taking this as A, this is also A. So the combined, it's next given the area of the bigger sector is 5 times the area of the smaller sector. So that means the angles also have the same thing. A is equal to 5B. Also, A plus B, if I'm taking this as angle B, A plus B is equal to pi, linear pair. A was equal to 5B, so this becomes 6B is equal to pi, or pi is equal, B is equal to pi by 6, or A is equal to 5 pi by 6. These are the two angles. You have to find out this expression. Also note one thing, tangent of theta, that is the angle between them, is mod of 2 root h square minus AB upon A plus B. Then you have to find out A plus B mod upon root of A minus B whole square plus 4h square. This is equal to cos B. Question number 49. The combined equation of two diameters of a circle which divide the circle in 4 sectors is given by this. So you have a circle in this question. And there are 2 diameters to it. Let's make that. So here you have 2 diameters. You are given the combined equation of these 2 diameters is given by ax square plus 2hxy plus by square is equal to 0. Now, if the area of the bigger sector is 5 times the area of the smaller sector, so area of bigger sector is 5 times area of smaller sector, right? If I'm assuming the area of the bigger, the angle subtended by the bigger sector is A, therefore this is also A. And when I'm assuming this is angle B, this is also angle B. So that means their angles are in the same ratio also. So angle A is equal to 5 times of angle B. You know, angle A plus angle B, 180 degree, that's pi. They are forming a linear pair. And this gives you 6 angle B is equal to pi, or angle B is equal to pi by 6, which will give you angle A is equal to 5 pi by 6. Simple as that, right? Now next, if I'm taking the angle between them as theta. So tangent theta is given by 2 of root h square minus AB upon h plus AB. So from here you can say, see, squaring both sides, I have tan square theta is equal to 4. There's no need of mod actually. So this is equal to 4 h square minus AB upon a plus b whole square. So adding 1 on both sides. Now this will be 4h square minus 4ab plus a plus b whole square upon a plus b whole square, which will be equivalent to 4h square minus a minus b whole square. See, this is from here you will have plus 2ab and there is minus 4ab. So this will remain as a square plus b square plus 2ab minus 4ab. This will be a minus b whole square, whole divided by a plus b whole square. Now you know 1 plus secant square theta is equal to secant, 1 plus tan square theta is equal to secant square theta by the trigonometric identities. So here you have cos square theta is equal to a plus b square upon 4h square minus a minus b whole square. Sorry, here is plus. Okay, so now from here, if I'm taking root on both sides, square root on both sides, you will have cos theta is equal to a plus b upon root of 4h square plus a minus b whole square. This is the cos b. See, theta over here, the angle is actually equal to b. In this question, theta is the angle between them, that is b. So cos b is equal to cos of pi by 6, which is a plus b upon root of 4h square plus a minus b whole square. Cos pi by 6 is equal to root 3 by 2. So this expression has the value as, the given expression was this expression has the value as root 3 by 2. That's it. Option B is the correct answer. Hope you got that. Let's move to the next question then. Question number 15, 9x squared minus 24xy plus 16y squared plus ax plus beta y. If plus 6 represents a pair of parallel lines of 1 unit apart, and one of those lines passes through 1, 1, then alpha upon beta is equal to. See, that was, I confused. There is alpha x. This is not ax. This one is alpha x. Now the equation, let's write that. 9x squared minus 24xy plus 16y squared plus alpha x beta y plus 6 is equal to 0. So let's compare it with the general equation, which is a x square plus by square, and here is h xy g x and beta, this is fy, 2gx, 2fy and 2hx plus c is equal to 0. So comparing that, you get the value of a as 9, b is equal to 16, h is minus 12, g is alpha upon 2, and f is beta upon 2, c is equal to 6. Now equation 1, it said in the question, equation 1 represents this equation. 1 represents a pair of parallel lines. So the lines are parallel if they satisfy this condition. A upon h is equal to h upon b is equal to g upon f, which makes it 9 upon minus 12 is equal to minus 12 upon 16 is equal to alpha upon 2 divided by beta upon 2, which gives you alpha upon beta is equal to simply minus 3 by 4. That's it. You have this answer. Option D. Hope you got that. Next is question number 51. If AB is the center of the circle passing through the vertices of the triangle, which are formed by 1, 2, and 3, these three equations, then A, B is equal to. You're given the three equations to be x plus y is equal to 6, 2x plus y is equal to 4, and x plus 2 y is equal to 5. So this is equation 1, 2, and 3. From equation 1 and 2, let's solve them simultaneously. From equation 1 and 2, I have 2x plus y is equal to 4, x plus y is equal to 6, minus x is equal to minus 2. And what will be the value of y? 8. Right? So from now, equation 1 and 3, x plus y is equal to 6 and x plus 2y is equal to 5 is equal to 5 minus. They will cancel. Minus y is equal to 1 or y is equal to minus 1. This on solving will give you x is equal to 7. Now from equation 2 and 3, second equation was 2x plus y is equal to 4, x plus 2y is equal to 5. So let's multiply this with 2. The equations will become 4x plus 2y is equal to 8. X plus 2y is equal to 5. Minus. You have 3x or x is equal to 1. And you will solve. You will get the value of y is equal to 2. So now the three vertices are I'm taking the A vertex to be minus 2, 8 from here. And from the second one, the B is 7, minus 1 and C is 1, 2. B 1, 2. So now you have to find out what we have to find out if A, B is the center of the circle passing through the vertices. Fine. So now the coordinate, you're given the coordinate. I'll say let the coordinate of circumcenter be PHK. In that case, you know one thing that PA is equal to PB is equal to PC. So apply the section formula. You have a H plus 2 whole square plus K minus 8 whole square is equal to H minus 7 whole square plus K plus 1 whole square plus this is equal to H minus 1 whole square, K minus 2 whole square. So that becomes, now let's open it. You have H square plus 4h is plus K square plus 64 minus 16K is equal to H square plus 49 minus 14H plus K square. I'm using these two equations first. Okay. H square plus 49 plus this plus K square plus 1 plus 2K. So these two will cancel and you have 18H minus 18K. This is 68 and here you have 50. So this is equal to minus 18, which gives you H minus K is equal to 1. Let it be number 4. Now I will pick up these two equations, which is, I'll solve here. So H minus 7 whole square K plus 1 whole square is equal to H minus 1 whole square K minus 2 whole square. H square plus 49 minus 14 H plus K square plus 1 plus 2K is equal to H square plus 1 minus 2H K square plus 4 minus 2H. H square K square will cancel and you have minus 12H and here was K and plus 4 k is equal to, this is 50 and this is 5. So this is equal to minus 45. This gives you, okay, I'll leave it as such. Now you have the two equations, minus 12h plus 4k is equal to minus 45. I'll multiply this equation by 4 and add to it. So you have 4k minus 4h minus 4k is equal to 4. You will cancel. You have minus 8h is equal to minus 41, or h will be equal to minus 41 upon 8. Question number 51. If A comma B is the center of the circle passing through the vertices of the triangle formed by this, and this, these three equations, then A comma B is. You're given the three equations as x plus y is equal to 6, 2x plus y is equal to 4, and x plus 2y is equal to 5. So let's solve these equations simultaneously. I'll name it as 1, 2, and 3. So from equation 1 and 2, from equation 1 and 2, you have 2x plus y is equal to 4, or x plus y is equal to 6, minus minus minus, you have x is equal to minus 2. And solving this, you will have the y's value as x plus 2y is equal to this. So you will get the y's value as 8. Now from equation 2 and 3, or 1 and 2, first of all, 1 and 3. 1 and 3. You have x plus 2y is equal to 5, x plus y is equal to 6, minus minus minus, y is equal to minus 1, and on solving, you will get x value as 7. From equation 2 and 3. Now it is 2x plus y is equal to 4, and I'm multiplying the third equation by 2. You have 2x plus 4y is equal to 10. Minus minus minus, this will cancel, and you have minus 3y is equal to minus 6, or you will get the y's value as 2, and on solving, you will get x is equal to 1. So what are the coordinates over here? 2 comma 8. Let this be coordinate A. Here the coordinates are 7 comma minus 1. Let it be the vertex P. And here the coordinates are 1 comma 2, and let it be the vertex C. Let's write it down. So let the A vertex to be equal to minus 2 comma 8, B to be 7 minus 1, and C 1 comma 2. I hope you're clear till here. Now let the coordinate of the circumference, the coordinate of the circumcenter B, it's given AB. So let it be AB. Now you know one thing, PA is equal to PB, and P B is equal to PC. Okay, you know actually PA is equal to PB is equal to PC, so you can pick any pair. Also the squares are equal, so I use the section formula now. P is AB, so this is going to be A plus 2 whole square plus B minus 8 whole square is equal to A minus 7 whole square, B plus 1 whole square. Similarly, here you will have A minus 7 whole square plus B plus 1 whole square is equal to A minus 1 whole square, B minus 2 whole square. This will be A square plus 4 plus 4A, B square plus 64 minus 16A is equal to A square plus 49 minus 14A plus B square plus 1 plus 2B. A square, B square will cancel each other. And you will have here 16A plus 14A. This is equal to minus 2A. Sorry, here is B, not this. So here you have 18a and minus 16. This will be minus 18b. This is 68, and over here, you will have this as minus 1. So this gives you a minus b is equal to minus 1. Hope you're clear. Now let's go with the second pair. Open it up. You have a square plus 49 minus 14a, b square plus 1 plus 2b is equal to a square plus 1 minus 2a, b square plus 4 minus 2b, a square, b square will cancel, and you will have minus 12a plus, sorry, here is 4b, okay, and 6b plus, this is 50 and this is 5, so you will have a 45 over here is equal to 0. So you have a minus 12a plus 6b is equal to minus 45. Now let's solve these two equations simultaneously. I'll multiply this with 12. You have 12a minus 12b is equal to minus 12, and minus 12a plus 6b is equal to minus 45. You have minus 6b is equal to minus 57, which gives you the b's value as this. So that's 19 upon 2. And on solving, you will get the a's value as, you see, you had a minus b is equal to minus 1. So a minus of 19 by 2 is equal to minus 1. A is minus 1 plus 19 by 2. That's equal to 17 by 2. So the coordinates become 17 by 2 and 19 by 2. That's it. You have the answer as options B. Hope you understood. Let's move to the next question, number 52. The locus of the midpoints of the chords of this circle drawn from the origin on it is. So this is the circle given to x squared minus 2x plus y squared is equal to 0. According to here, the center which is given by minus g minus f, the center is equal to minus of half of x. This is equal to 1 comma 0. Okay, now the locus of the midpoints of the chords of the given circle, the locus of the midpoints of the chords of given circle from the point 0, 0, that's origin, is a circle whose extremities of diameter is center and given point. So the locus of the midpoints of the chord, locus of midpoint of the chord is x minus 1 into x minus 0 plus y minus 0 into y minus 0 is equal to 0, which gives you x square minus x plus y square is equal to 0, or x square plus y square minus x is equal to 0, which is option A. Hope you understood. Next is question number 53. It says the number of possible common tangents that can be drawn to the circles this and this is. So here this is the equation of the two circles. The first one is given by x squared plus y squared plus 4x minus 6y minus 3 is equal to 0. And the second is x squared plus y squared plus 4x minus 2y plus 1 is equal to 0. So here you have the g's value. So g is given by half the coefficient of x, which is 2, and f is given by half the coefficient of y, which is equal to minus 3. C1 is equal to minus 3. So from here, the center, which is given by minus g, minus f. So the center in this case is minus 2 comma 3, and radius, this is center 1 and radius 1. Radius is given by g square plus f square minus of c. G is 4, 2 square minus 2 square, that's 4, plus 3 square is 9. Minus of minus 3 is equal to plus 3. This is gonna give you 16, that is equal to 4. Okay, this is for the first circle. So you have the center as minus 2 comma 3 and radius as 4. And the second circle, the same thing. The value of g is equal to 2. Half the coefficient of x, half the coefficient of y is f. So f is equal to minus 1. C is 1. From here, you have the center minus g minus f. So that is minus 2 and 1. And radius, that is r2. Radius is given by root of minus 2 square, which is 4, plus 1 minus c square, which is 1, that gives you 2. So I have the second circle center as minus 2 comma 1 and radius as 2. Right, hope you got that. So now the distance between the centers, that is c1 c2, distance between the centers c1 c2 is equal to root of minus 2 plus 2, which is 0 square, plus 3 minus 1, which is 2 square, that is equal to 2. Now the distance between the centers come out to be 2, and radius 1 is equal to 4, radius 2 is equal to 2, and the distance between these two radius, difference between these two radius is equal to 2 again. Here you get C1, C2 is equal to R1, R2, which means circles touch each other internally. Touch internally at 1 point. Let's draw the figure for this. So you have this bigger circle and there is another circle and they touch each other at 1 point. So there is only one possible tangent. Tangent number of tangent is equal to 1. That's it. So you have option C as the correct answer. Hope you understood this. Let's move to the next question, number 54. The equation of the circle passing through 1, 1 through the points of intersection of these two circles is. So now you have to find out the equation of the circle which is passing through this point and which is also passing through the point of intersection of these two circles. Okay. Okay, so let the two circles here be, not let, actually I'm taking here S1 and S2. S1 is x square plus y square plus 13x minus 3y is equal to 0. And the second one is 2x square plus 2y square plus 4x minus 7y minus 25 is equal to 0. Equation of the circle which is passing through the point of intersection of these two circles is given by, I'll say, equation of the circle which is required is given by S1 plus lambda S2 is equal to 0, which gives you x square plus y square plus 13x minus 3y plus lambda 2x square 2y square 4x plus 7y minus 25 is equal to 0. Now this is given that this circle passes through 1 and 1. This circle passes through 1, 1, which makes the equation as 1 square plus 1 square plus 13 minus 3 plus lambda 2 plus 2 plus 4 plus 7 minus 25 is equal to 0. This will make the equation as 12 plus lambda. This is 8 plus 15. So this is minus 10 is equal to 0. From here, you get the value of lambda as a minute 8 and 15. Sorry, here was minus 7y and this is, so this is equal to minus 7y. And this equation becomes 12 plus lambda into minus 24 is equal to 0, which gives you the value of lambda as 1 by 2. That's it. Now the equation, it pretty easily becomes, the equation was x squared plus y squared plus 13x minus 3y plus 1 by 2, 2x squared plus 2y squared plus 4x plus minus 7y minus 25 is equal to 0, which on solving will give you 4x squared plus 4y squared plus 30x minus 13y minus 25 is equal to 0. Now this is equation option A. Hope you understood. Let's move to the next question then. Question number 55. If the circles x minus 2 whole square plus y minus 3 whole square is equal to 25 and this touch internally at alpha beta, then alpha plus beta is equal to. Basically, you have to find out alpha and beta, so you'll solve the question. So the first circle S1 and let this be S2. Now in the circle S1, you are given x minus 2 whole square, y minus 3 whole square is equal to 25, which gives you the center C1 as 2, 3 and the radius is equal to 25 root, which is equal to 5. Okay, this is pretty easy to go with. This is radius 1. Now for the circle 2, you are given the equation x square plus y 25x square plus 25y square minus 40x minus 70y minus 160 is equal to 0. I'll divide both the sides with 25. So you have x squared plus y squared minus 40 upon 25x minus 70 upon 25y minus 160 upon 25 is equal to 0. So here, what is the center? Minus half the coefficient of x, which is 20 upon 25, or that is equal to 4 by 5. And f is minus half the coefficient, like the y coordinate is minus half the coefficient of y, which is minus 35 upon minus of minus 35 upon 25, which gives you 7 upon 5. Right. Now, here the radius is given by root of g square plus f square minus c. So minus minus plus this c. Okay, this is c. This is g. G is minus half the coefficient. Sorry, not minus. G is half the coefficient of x and f is half the coefficient of y. Solving this, you will have 16 plus 49 plus 160 upon 25, or this is equal to 49 and 16, 5 and 6, 160. So this is 225. 225 upon 25, which gives you 15 upon 5 or 3. So the second radius came out to be 3. Okay. Here R1 was equal to 5 and C1 was equivalent to 2 by 3. And here the C2 is equivalent to 4 by 5, 7 by 5. Now, if the two circles, they are having, okay, let's write down. If circle S1 and S2 with center C1 with X1, Y1 and C2 as X2, Y2 having radius R1 and R2 respectively touches each other internally, then coordinates of point of contact is given by, now note down this formula. This is R1 X2 minus R2 X1 whole divided by R1 minus R2, comma R1 Y2 minus R2 Y1 upon R1 minus R2. Now we have all the values. Let's put them. You get the alpha and beta as this is 5 into 4 by 5 minus 3 into 2 upon 5 minus 3, 5 into 7 by 5 minus 3 into 3 upon 5 minus 3. This gives you 4 minus 6 upon 2, that is equal to minus 1. And this is 7 minus 6 upon 2, 7 minus 9 upon 2, that is equal to minus 1 again. So alpha is equal to minus 1, beta is equal to minus 1, and the sum of the two is equal to minus 2. That's it. You have option B as the answer. Hope you understood. Next is question number 56. A point on the parabola whose focus and vertex are respectively this and this is, you have to find out point on the parabola whose focus and the vertex is. Okay. First of all, the equation of the parabola, the general equation is given by y minus k square is equal to 4a x minus h, where focus is h plus a, comma k, and vertex is hk. Now you are given that the vertex is equal to 1, comma minus 2, and this is equal to 5 by 4 minus 2. So this gives you h is equal to 1, k is equal to minus 2, right? H plus a is equal to 5 by 4, which will give you a is equal to 5 by 4 minus 1, which is equal to 1 by 4. Now we'll put all of these values in equation 1. Let's say this is equation 1. Filling all values in equation 1, you will get y plus 2 square is equal to 4 into 1 by 4 into x minus 1, which will give you y plus 2 square is equal to x minus 1, or that's it. So if I see which of these points satisfy, you have a as 4 comma 10. Okay, give me a minute. 4 comma 10, the given options are, and 15 comma 2, 3 comma minus 1, 10 comma 1. 4 comma 0, no, this is not the one, because if I'm saying 4 comma, this is 6 square and that's equal to minus 1, that's not true. This is option A, so this is incorrect. Option B is 17 square is equal to 1, that's also incorrect, so B is also wrong. C says 5 square is equal to minus 2, no, wrong. And D says 12 square is equal to, so sorry for this. Question number 58. A focus of an ellipse having the centricity 1 by 2 is at origin. So centricity is given to you 1 by 2 and the focus of an ellipse is at origin. Directrix is the line x is equal to 4. Then the equation of one such ellipse is. So the general equation of the ellipse is given by equation of ellipse is x minus alpha square upon a square plus y minus beta square upon b square is equal to 1. Right? And here the foci is alpha plus minus a e comma beta. And the equation of directrix is x is equal to alpha plus a upon e, where e is eccentricity. right? Now the foci is given to you alpha plus minus AE comma beta, that is equal to 0. This is the focus, right? That means alpha plus AE is equal to 0 and beta is equal to 0. E's value was 1 upon 2. So this becomes alpha plus A upon A upon 2 is equal to 0. Let's name this as equation 1. Further, let's move to the directrix. Directrix equation was given by x is equal to alpha plus A upon E. Now this is given to you as 4 in the question. You are given that the directrix is equal to 4. So alpha plus A upon 1 upon 2 is equal to 4, which gives you alpha plus 2A is equal to 4. So this is equation 2. Let's solve 1 and 2 simultaneously. You have alpha plus A upon 2 is equal to 0. Minus, minus, minus. So you have here 3A upon 2 is equal to 4, which gives you A is equal to 8 by 3. And from equation 1, you have alpha plus A upon 2 is equal to 0. So this becomes alpha plus 4 upon 3 is equal to 0, which gives you the value of alpha as minus 4 by 3. Also, eccentricity square is 1 square, 1 minus b square upon a square. Eccentricity was 1 by 4. Sorry, eccentricity was 1 by 2. So 1 by 2 square is 1 by 4. That's equal to 1 minus b square upon a. A is equal to this. So this is equal to 8 upon 3 whole square. That makes 1 upon 4 is equal to 1 minus b square upon 64 upon 9. That is 1 by 4 is equal to 1 minus 9 upon 64 into b square. 9 upon 64 b square is equal to 1 minus 1 by 4, which is equal to 3 by 4. This will cancel and this will cancel at 16. So b square is equal to 16 by 3. Now we have everything. We can form the equation of the ellipse. Equation of the ellipse becomes, what was that equation? X minus alpha whole square upon a square plus y minus beta whole square upon b square is equal to 1. Alpha value was minus 4 by 3. A's value was, what is A's value? 8 by 3. So this is equal to 8 by 3 square plus y minus beta, that was 0. So y minus 0 square, and b's value came out to be, b square came out to be 16 by 3, right, from here. That is equal to 1. So let's solve it. You have this as 9 upon 64 x minus 4 by 3 whole square plus 3 upon 16 y square is equal to 1. I'll take the LCM. Okay. So this is equal to 64, 9 x. Wait. Okay. So this is equal to x minus 4 by 3 whole square plus 12y square. It's a small change. The value of alpha was equal to minus 4 by 3. So this becomes plus 4 by 3. Okay, this was the correction. This is the correction. That's equal to 1. So this will be 9 upon 9, 3x plus 4 whole square plus 12y square is equal to 64. They will cancel and you will have the value of the equation as 3x plus whole square. 3x plus 4 whole square plus 12y square is equal to 64. This is answer to the question. Let's check with the options. You have option D as the answer. Hope you got that. Next is question number 59. The area in square units of a quadrilateral formed by joining the foci of the two ellipses, which are these two, is. Okay, so if I take the general equation, x square upon a square, y square upon b square is equal to 1. Here the foci is plus minus a e comma 0. When a is greater than 0, and it is 0 plus minus b e when b is greater than a. Okay, so now let's say this is s. S is equivalent to x square upon 9, y square upon 5 is equal to 1. You are having the equation. See, this is a is greater than b. 3 is greater than, like 5 root will be of course greater than 3, less than 3. So the foci is given by plus minus a e comma 0. Here a square is 9, which gives you a is equal to plus minus 3, and b square is equal to 5, which gives you b is equal to root of 5. Right? And I have the value of a over here from here. And what is the value of e? I can find out e by using the formula a square minus b square upon a square, which gives you 9 minus 5 upon 9, that is 4 upon 9, which is 2 upon 3. Okay. Therefore, foci is AE, that is A was equal to 3. I'll write it again. Foci A is plus minus A, that is 3 into 2 by 3, comma 0. So I have the two values for it, that is A is 2, comma 0 and B is minus 2, comma 0. This was for the first ellipse. And let's go for the second one. Let's say that S dash. So S dash is equivalent to x square upon 5 plus y square upon 9 is equal to 1. So here a square is equal to 5, which gives you a is equal to root 5 plus minus, and b square is equal to 9, which gives you b is equal to plus minus 3. Here you have b greater than a, so foci is given by 0 plus minus be. Okay, now again I have to calculate, wait, this is for S dash. So again, I have to calculate E over here. In this case, E will be given by B square minus A square upon B square. 9 minus 5 upon 9, which gives you 2 by 3. So in this case, the foci will be C. If I'm taking this as C, okay, foci, first of all, it will be given by 0 plus minus BE. So this is equivalent to 0 plus minus B's value was 3. And E is 2 by 3. So you have two values of the foci, that is 0, 3 and 2. There is 0, 2 and D 0, minus 2. Let's understand this whole situation using the figure. If you are having this as coordinate axis. So here is the point 2, 0. Here is the point minus 2, 0. This is the point 0, 2 and 0, minus 2. This is A, B, C and D. So let's join them. This is forming what? This is forming a rhombus. Right. So now area of quadrilateral AD, this is D. ADBC is equal to 4 into area, if I'm taking O, area of triangle OAC, that is equal to 4 into 1 by 2 into 2 into, that's see, area of the triangle is half into base into height. So half into base into height, that will give you 8. Okay, 4 2s are 8 square units. This is answer to the question, 8 square units, option D. Hope you understood this. Next is question number 60. The lines x cos alpha plus y sin alpha is equal to P, where A belongs to R. Real numbers are the chords of the hyperbola, this, and they subtend a right angle at the center of the hyperbola The locus of the poles of these lines with respect to the given hyperbola is. Okay, first I'm assuming let PHK be the pole of chord of the hyperbola. X square minus 9 y square. This, let's name this as equation 1. Then the equation of the chord. Then equation of the chord is hx upon 9 minus ky upon 36 is equal to 1. So that is equation 2. Combining both of them, combining 1 and 2, maintaining homogeneity, you have x square upon 9 minus y square upon 36 is equal to hx upon 9 ky upon 36 whole square. Now, this is because the chord subtend right angle at the center, because chord subtends right angle at the center. This means coefficient of x square plus y square is equal to 0. Coefficient of x square plus coefficient of y square is 0, which makes 1 upon 9 minus h square upon 9 square minus 1 upon 36 minus k square upon 36 square is equal to 0. Okay, so using these two equations, right? Okay, let's solve it further. You have h square upon 9 square plus k square upon 36 square is equal to 1 by 9 minus 1 by 36. Okay, so next, solve it. Let's solve it. You have, I'll say 36 square into 9 square is equal to 36 into 9, 36 minus 9. This gives you h 36 square into h square plus 9 square into k square. Okay, so one of these will cancel like this, and you will have a 36h square, 36 square, h square plus 9 square k square is equal to 27 upon 36 into 9. Okay, I'll do one thing. I'll take 9 square common from here. So 9 square will be taken common. You will be left with 4 square h square plus k square upon 36 into 9 is equal to 27. So this will cancel and this will cancel with 4. You have 16h square plus k square is equal to 108. Or the general equation will be 16x square plus y square is equal to 108. This was the locus. Here was the locus was hk, and the general equation will be given by 16x square plus y square is equal to 108. That is option C. Hope you understood this. Next is question number 61. It says if this is the centroid of the tetrahedron with these 4 vertices, then which of the following is true? Easy question, right? See the vertices of the tetrahedron. These are the 4 coordinates. Centroid in this case, centroid of the tetrahedron is given by, see, a plus 1 plus 4 plus 1, a plus 1 plus 4 plus 1 upon 4, 2 plus b plus 0 plus 1 upon 4, 1 plus 4 plus c plus 7 upon 4, which gives you a plus 6 upon 4. This is b plus 3 upon 4, c plus 12 upon 4. So you're given that this is equivalent to 9 by 4, 5 by 4, and 15 by 4. So that means a plus 6 by 4 is equal to 9 by 4. B plus 3 by 4 is equal to 5 by 4, and C plus 12 by 4 is equal to 15 by 4. That gives you A's value as 3, B's value as 2, and C's value as 3. Right? You have to calculate, you have to find out, okay, A is 3, B is 2, and C is 3. That means A is equal to C is equal to B plus 1, which is option D. Right? Correct? Next is question number 62. Hope you understood the last question. Students, before solving this question is a quick reminder to visit our website www.examsnet.com to practice not only this but similar type of multiple entrance exam question papers for a fruitful preparation. You can also download our app. The link is available in the description box. Here we go. The question number 62. The direction cosines of the line making angles pi by 4 and pi by 3 and theta, where theta lies in the first quadrant, respectively with x, y, and z axes are. Okay, so here first of all, I'll assume that the two angles are alpha and beta, and the third one is gamma, that is equal to some theta, right? Then cos square alpha plus cos square beta plus cos square gamma is equal to 1, or sin square gamma is equal to cos square alpha plus cos square beta. I can write it like this because I'll take this cos square gamma on the right hand side. So 1 minus cos square gamma is equal to sin square gamma. Right. This gives you sin square theta is equal to cos square pi by 4 plus cos square pi by 3. Cos square pi by 4 is 1 by root 2 whole square, and this is equal to cos pi by 3 is equal to 1 by 2 whole square. So this gives you 1 by 2 plus 1 by 4, which is 3 by 4. That means sin theta is equal to root 3 by 2, which is the value for sin pi by 3, which gives you theta value as pi by 3. Therefore, the direction cosines are cos pi by 4, cos pi by 3, and cos pi by 3, which is 1 by root 2, 1 by 2, and 1 by 2. That's it. So you have option A as the answer. Right? Hope you understood. Next is question number 63. The point on the plane 2x minus 2y plus 4z plus 5 is equal to 0 that is nearer to this point is, okay, you are given this plane 2x minus 2y plus 4z plus 5 is equal to 0. What are the direction ratios of the normal? That is 2, minus 2, and 4. Right. Now the equation of the line passing through, equation of the line passing through 1, 3 by 2, comma 2, and with direction ratios and direction ratios 2, comma minus 2, comma 4, sorry, not minus 4, 4 is x minus 1 upon 2, y minus 3 by 2 upon minus 2, z minus 2 upon 4 is equal to r. Here x is equal to 2r plus 1, y is equal to minus 2r plus 3 by 2, and z is equal to 4r plus 2. Right. Now this point also lies on the given plane. This point also lies on the given plane. Therefore, if I'm using this in the given plane, which is given by this equation, so this will make 2 into 2r plus 1 minus 2 minus 2r plus 3 by 2 plus 4r, that is 4r plus 2. Okay. Plus 5 is equal to 0. Now solving this, you will get 24r plus 12 is equal to 0, or r will be minus 1 by 2. Therefore, the required point is 2 into minus 1 by 2 plus 1 minus 2 into minus 1 by 2 plus 3 by 2, 4 minus 1 by 2 plus 2, which makes the point as this is 0, 5 by 2, and this will be 0 again. So this is the required point, 0, 5 by 2, comma 0, option A. Hope you got that. Next is question number 64. Limit x approaching 0 log of x upon 1 minus x. So see, if I'm putting x is equal to 1, this will be log 1 upon 1 minus 1. This is 0 upon 0 form. So I have to apply L'Hospital's rule. This will be very easy to solve using that. Using L'Hospital rule, this can be written as limit x approaching 1 upon x upon minus 1. See, in the L'Hospital's rule, I'll find out derivative of the numerator and the denominator. So this will be limit. I'll remove the limits now. Okay. So basically, this will be limit x approaching 1 minus 1 upon x. So this will be 1 only, minus 1 only. Option B is the correct answer. Hope you got that. Next is question number 65. Let fx is equal to this, where x is not equal to 0. In order that fx is continuous at x is equal to 0, f0 is to be defined as what of this? You are given that fx is 2 minus root of x plus 4 whole divided by sine 2x, right? And okay, if I'm taking f of 0, this will be limit x approaching 0 for fx, right? So this is equal to limit x approaching 0 for 2 minus root of x plus 4 upon sine 2x. See, over here, again, this is of the form like 0 upon 0. So I'll have to, this is 0 upon 0 form. So I will again apply my L'Hospital's rule. Applying L'Hospital's rule, this becomes limit x approaching 0 minus 1 by 2 x plus 4 upon 2 cos 2x, right? So this will be written as limit x approaching 0 minus 1 upon 4 into this cos 2x. I'll put x is equal to 0 now. So this will be minus 1 upon 4 into 2 into 1. That is minus 1 by 8. So we have option A as the correct answer. Hope you got this. Let's move to the next question, number 66. If fx is equal to 1 plus cos x, where x is less than equal to 0 and a minus x for x between 0 and 2 is continuous everywhere, then what is a square plus b square? So you are given that fx is having these three values for the different values of x. Okay. Now you're given that fx is continuous everywhere. It is continuous everywhere. If it is continuous everywhere, that means you are given fx is continuous everywhere, which means this is continuous at the two breaking points also, that is x is equal to 0 and 2. It is continuous at x is equal to 0 and x is equal to 2. Therefore, the left hand limit at x is equal to 0 is equal to the right hand limit at x is equal to 0. Now, this is equal to f0. So, let's write it down. Limit x approaching 0 minus f x is equal to limit x approaching 0 plus fx is equal to 2. What is fx? This is equal to, for c, for around 0, less than 0, this is equal to 1 plus cos 2x, cos x. And for x 0 plus, it is given by a minus x. See, for less than 0, it is 1 plus cos x. And for greater than 0, it is a minus x. So this is minus here, limit x approaching 0 plus, this is a minus x. Now this value is equal to 2 from here. Okay. So now this will be 1 plus 0 is equal to a minus 0 is equal to 2, which gives you, cos 0 is 1. Okay. Which gives you 2 is equal to 2. A is equal to 2. That's it. Now, let's move to the second one, that is x is equal to 2. Since the function is continuous everywhere, therefore the left-hand limit at x is equal to 2 is equal to right-hand limit at x is equal to 2, and both are equal to f of 2. Right? So, limit x approaching 2 minus f x is equal to limit x approaching 2 plus fx is equal to f of 2 gives you a minus 2, because that is a minus x. I'll be using this particular formula. And here you will have limit x approaching, for 2 minus you will use a minus x, and for 2 plus you will use x square minus b square. This is equal to, a was equal to 2, so 2 minus 2. Now, I'm filling x is equal to 2, so this becomes a was already 2. 2 minus 2 is equal to 4, and minus b square, that's equal to 0. So that means 0 is equal to 4 minus b square is equal to 0, which gives you the b's value as, actually b square is equal to 4. I need to find out b only, b square only. You have to find out a square plus b square. A square plus b square. A was 2 and b square is 4. So that gives you 8. We have option B as the correct answer. Hope you understood this. Next is question number 67. If x is equal to 5, 1 minus sine t, and y is equal to 5, t plus cos t, then dx upon dy is equal to. Okay, so x is equal to 5, 1 minus sine t, and y is 5t plus this. Such type of questions, I'll find both the derivatives with respect to t. So this will be 5 minus cos t, and here dy by dt will be equal to 5, 1 minus sine t. Now dy by dx is given by dy by dt divided by dx by dt. Okay, so this is the, sorry, you have to find out dx upon dy. So this will be reversed. Dx upon dy is equal to dx upon dt divided by dy upon dt, which is minus 5 cos t, 5, 1 minus sin t. They will cancel, and you will have cos t upon, I'll write it as sin t minus 1, because this minus I'll utilize over here. So cos t upon sin t minus 1, this is option B. Hope you understood this. Then let's move to the next question. Question number 68. Let g and f be these two functions which are defined as gx is equal to this and fx is equal to this. So in the interval -2, 2, f is not differentiable at x is equal to. You are given the function gx is equal to -1 if x lies between -2 and 0, and it's equal to x square minus 1 if x lies between 0 and 2. So let's make the graph for this. If this is the coordinate axis and x and y axis, so it is equal to -1 for x belonging to -2, 0. So if it is -2 and here is here is 0, so this will be equal to -1. So it will look something like this. This is -1, 1, 2, and 3. So this function is somewhat like this. Now, when it reaches 0, the function changes to x square minus 1. So that means x square minus 1, if I'm putting the value of x as anything, this will look as something like this. Okay, here is x is equal to -2. Sorry, 2. So this is the function for this. This is the graph for this function. Next is g of x modulus. So that means this function is equal to 1 for x between -2 and 0. And this is equal to mod of x square minus 1 if it lies between 0 and 2. Let's make the graph. So here the graph will be something like -2 and this is 0 and this is 2. So this will be 1 only like this. And then for x less than 1, see if it is 1 over here, x less than 1, it will drop like this. And after it reaches 1, it will suddenly rise till x is equal to 2. So this is type of function mod of gx. Next is g of mod of x. So this is equal to, now this function, see it will remain the same. Now the only thing is, now I'll be considering the only positive values for x. So the graph for this one will be something like this. Graph for mod of x is the graph something like this. You are given fx is equal to g of x mod plus g of mod of x plus 2. So here graph gx is making, in the second one, graph gx is making a sharp turn at x is equal to 1. Therefore, this is not differentiable. X is equal to 1. G of x is making sharp turn. Therefore, fx is not differentiable at x is equal to 1. Hope you understood this. So we have option B as the correct answer. Let's move to the next question. Question number 69. Hope you understood this. Consider the following statement. If a function is differentiable at a point P, then it is not continuous at P. This statement, if a function is differentiable at P, then it is continuous at P. So this statement is wrong. Second, if a function is not continuous at x is equal to a, it's not differentiable at x is equal to a. This is absolutely true. See, if a function is differentiable at x is equal to a, then definitely it is continuous at x is equal to a. And if it is not continuous at x is equal to a, it's not differentiable. That means A is incorrect and B is correct. Let's move to the third one. F of x is equal to mod of x. See, for this, the graph looks something like this. F of x is equal to mod of x. Then fx is not differentiable but continuous on R. See, mod of x is definitely it's continuous on R, but it makes a corner at x is equal to 0. Here. It's making a corner over here. Therefore, mod of x is not differentiable here. At x is equal to 0. So that means this is true. Let's move to the last. D option, fx is equal to x minus greatest integer function of x. Now this is equal to fractional put function. In this case, f dash of 1 is not equal to 1, which means this statement is also wrong. D option is wrong, which means we have B and C only as the correct answer. Hence, option B is correct. Hope you got that. Let's move to the next question, number 70. If x square plus xy plus y square is equal to k, then d square y upon dx square is equal to. You are given the equation as this. So let's differentiate with respect to y. So this becomes 2x plus x into dy by dx plus y plus 2y dy by dx is equal to 0. Let's name this as 1 and this as 2. Here you can write down dy by dx is equal to minus 2x minus y upon x plus 2y. Let's name this as equation number 3. Now, I'll differentiate equation 2 again. Differentiating equation 2 with respect to x. You have 2 plus x d square y upon dx square plus dy upon dx plus dy upon dx plus 2y d second derivative of y plus dy upon dx whole square multiplied by 2 is equal to 0. Right? Further, this will be 2 plus x plus 2y d square y upon dx square plus 2 dy upon dx plus 2 dy by dx square is equal to 0. I'll put the value of dy from here, equation 3. So using equation 3, you have 2 plus x plus 2y d square y upon dx square plus 2 into minus 2 x minus y upon x plus 2y plus 2 into minus 2x minus y upon x plus 2y is equal to 0. So here, okay, now I can write it as x plus 2y d square y upon dx square plus 2 minus 2 into 2x plus y upon x plus 2y minus 2 2x plus y upon x plus 2y is equal to 0. This is a square. I missed. Okay, now let's take the LCM. You have x plus 2y cube into d square y upon dx square plus 2x plus 2y square minus 2x plus y x plus 2y minus 2 is equal to 0. I'll take the LCM, cross product of the denominator with 0. It will give you this. So let's solve it further. X plus 2y whole cube d square y upon dx square plus 2 into x square plus 4y. X square plus 4y square plus 4xy minus 2 into 2x square plus 4xy plus xy, which will be 5xy, and 2xy minus 2 is equal to 0. This will be x plus 2y cube d square x upon dx square plus 2x square plus 8xy plus 8y square 4x square minus 10xy minus 4y square minus 2 is equal to 0. That is x plus 2y cube d square y upon dx square. Now you will have 2x square and here is minus 4y square. One thing I missed, I forgot to write this over here. I thought they are the same. Okay. So this will be equal to minus 2 into 2x plus y whole square is equal to 0. Similarly, minus 2 into 2x plus y whole square is equal to 0. And now I'll write it as minus 2x square minus 2xy plus 4y square minus 2 into 4x square plus y square plus 4xy is equal to 0, or minus 2x square minus 2xy plus 4y square minus 8x square minus 2y square minus 8xy is equal to 0. This will give you x plus 2y whole cube d square y upon dx square. Now this will be equal to question number 70. If x square plus xy plus y square is equal to k, then you have to find out the second derivative of this function with respect to x. The given function, the given equation is x square plus xy plus y square is equal to k. Let's differentiate it with respect to x. You have 2x plus x into dy by dx plus y plus 2y into dy by dx is equal to 0. From here, you can write down dy upon dx is equal to minus 2y minus 2x minus y upon x plus 2y, or that's equal to minus 2x plus y upon x plus 2y. Let's name them as number 1 equation, number 2, and number 3 equation. Now, differentiating equation 2 again. With respect to x, you will have 2 plus x d square y upon dx square plus dy upon dx plus dy upon dx again plus 2y d square y upon dx square plus 2 dy upon dx square is equal to 0, which gives you 2 plus x plus 2y d square y upon dx square plus 2 dy upon dx plus 2 dy upon dx square is equal to 0. You can write it as x plus 2y d square y upon dx plus 2 plus 2. Okay, I'll write down instead of dy, I'll use equation number 3 to fill in the value. Okay, so this will be plus 2 minus 2 2x plus y upon x plus 2y plus 2 into 2x plus y square upon x plus 2y square is equal to 0. Now let's take the LCM of x plus 2y. You will have x plus 2y cube is equal to d square y upon dx square plus 2x plus 2y square minus 2 into 2x plus y into x plus 2y plus 2 into 2x plus y square is equal to 0. I'll leave it as such. 2x plus 2y whole cube d square y upon dx square plus 2 into x square plus 4y square plus 4xy minus 2x plus 4xy plus xy, which will give you 5xy plus 2y square plus 2 4x square plus y square 4xy is equal to 0, which will give you x plus 2y cube d square y upon dx square plus 2x square plus 8y square 8xy minus 4x minus 10xy minus 4y square plus 8x square plus 2y square plus 8xy is equal to 0. This gives you further this. Now 2x square, and here you have 8x square plus 2 and plus 8. And here also, give me a minute. It was 2x square. This x square is there. And when I'll open, this is 4x square. Okay, so here you have plus 6x square. I have used these three terms. And 8 minus 4 plus 2. This again gives you 6y square. 8 minus 10 plus 8. So that's equal to 6xy. That's equal to 0. Now this is x plus 2y cube. Second derivative of y with respect to x. I'll take 6 common. X square plus y square plus xy is equal to 0. And what was the value of k? This is the value of k. So this is equal to 6k x plus 2y cube d square y upon dx square. So here d square y upon dx square is equal to minus 6k upon x plus 2y whole cube. This is answer to the question. Let's check. You have option A as the correct answer. Hope you understood. Next is question number 71. You have to find out the approximate value of this given expression up to 3 decimal places. You can write it as 8.01 whole raised to power 4 by 3 plus 8.01 whole raised to power 2. This can be written as 8 plus 0.01 whole raised to power 4 by 3 plus 8 plus 0.01 whole square. So that's equal to 8 raised to power this, or 4 by 3. I'll take 1 plus 0.01 divided by 8 raised to power 4 by 3 plus 8 square. I'll take common. 1 plus 0.01 upon 8 whole square. Now this is equal to 8 raised to power 4 by 3. 1 plus, that's equal to 0, 0, 1, 2, 5. 4 raised to power 3, 8 square. 1 plus 0, 0, 1, 2, 5 whole square. Right? So see over here, this is equal to 2 raised to power. This can see 8 raised to power 1 by 3, that's equal to 2. And 2 raised to power 4, that's 16. So I'll write down 16 over here, 16. And this is 1 plus 4 by 3 into 0.00125 plus 64, 1 plus 2 into this. So I'm using that formula a plus b, or 1 plus a 1 plus a raised to power n. This is given by 1 plus n into a raised a and so on, right? So that's equal to using the, see over here, I'm using the binomial expansion. And since the order is very small, so I'm ignoring the higher order terms. This will give me 16 multiplied by 3.005 upon 3 plus 64 multiply. This will be 1.0025. And on solving further, you will get the value as 80.186. This is the correct answer to the question. 80.186. That's option D. Hope you got that. Next is question number 72. If the tangent at the point P on the curve y is equal to 4x raised to power 4 plus x is perpendicular to the tangent to the same curve at origin, then point P is. You are given the curve y is equal to 4x raised to power 4 plus x. Let's name this as 1. Now, differentiating with respect to x, you have dy by dx is equal to 16x cubed plus 1. And now differentiating this equation again. Question number 71, you have to find out the approximate value of this given expression up to 3 decimal places. Okay, so this is the given expression 8.01 raised to power 4 by 3 plus 8.01 raised to power 2. This can be written as 8 plus 0.01 raised to power 4 by 3 plus 8 plus 0.01 raised to power 2. So I'll take 8 raised to power 4 by 3 common. This will be this expression plus 8 square 1 plus 0.01 upon 8 whole square. Now 8 raised to power 1 by 3, that's 2, and 2 raised to power 4 is 16. So you will write it as 1 plus 0.00125, 4 raised to power 1, sorry, whole raised to power 4 by 3 plus 64, 1 plus 0.00125 whole raised to power 2. Now I'll be using the binomial expansion and I'll be neglecting the higher order terms. You will have 16 and this can be written as 1 plus 4 by 3 into 0.00125 plus 64 into 1 plus 2 into this. Okay, so that's equal to 16 into, you'll solve it and get 3.005 upon 3 plus 64 into 1.025, which on solving the total will come out as 80.186. So we have option D as the correct answer. Hope you understood. Next is question number 72. If the tangent at the point P on this curve is perpendicular to the tangent to the same curve at origin, then P is. You are given the curve as y is equal to 4x raised to power 4 plus x. Let's differentiate with respect to x. You have 16x cubed plus 1. So let's say the point P having the coordinates as x1, y1. So slope of the tangent at P, that's x1, y1 is given by m1 is equal to dy by dx at x1, y1. This is equal to 16x1 cube plus 1. Similarly, slope of tangent at 0, 0 is m2 is equal to dy by dx at origin, which is going to give you the value as 1. So now Since both the tangents, they are perpendicular to each other, therefore, according to question, the product of their slopes is equal to -1, which gives you 16x1 cube plus 1 multiplied by 1 is equal to -1, or this gives you 16x1 cube plus 1 is equal to -1, which gives you x1 cube is equal to -2 upon 16. That's equal to -1 by 8. So here you have x1 value as -1 by 2. If x1 is -1 by 2, what will be the value? See, using this equation, what will the value of y1? y1 will be equal to 4x raised to power 4 plus it was x, which is -1 by 2. So 4 into 1 by 16 minus 1 by 2, that's 1 by 4 minus 1 by 2, which gives you -1 by 4. So you got the two values, x1, y1, that's equal to -1 by 2 and -1 by 4. So here you have option A as the answer. Hope you got that. Next is question number 73. The angle between the curves 2x squared plus y squared is equal to 20 and 4y squared minus x squared is equal to 8 at a point where they intersect in the fourth quadrant is. See, here you have 2x squared plus y squared is equal to 20. Now, on differentiating it with respect to x, you get dy, first of all, 2x plus 2y dy by dx is equal to 0, which gives you dy by dx is equal to minus x upon y. Sorry, here is 4y. I'll do this again. You have the two curves as 2x squared plus y squared is equal to 20. So, on differentiating with respect to x, you have 4x plus 2y dy by dx is equal to 0, which gives you dy by dx is equal to minus 2x upon y, right? And you have the second one as 4y square minus x square is equal to 8. It's differentiated with respect to x. You have 8y dy by dx minus 2x is equal to 0. Here you will have dy by dx is equal to x upon 4y. Okay, so let's name number the equations. This is equation number 1. This is 2, 3, and 4. These are the 4 equations. Now, point of intersection of curve 1 and 2, 3, sorry. Point of intersection of curve 1 and 3, these two is given by, let's solve them simultaneously. This will be, wait, we have 2x squared plus y squared. So this can be given as 2x squared plus y squared is equal to 20. And the second one was 4y squared minus x squared is equal to 8. This gives you x squared is equal to 4y squared minus 8. So 2 into 4y squared minus 8 plus y squared is equal to 20. 8y squared minus 16 plus y squared is equal to 29. Y squared is equal to 36. Y squared will be 4, which will give you y is equal to plus minus 2. Okay, if y is equal to plus minus 2, what will be x squared? It will be equal to, give me a minute. X squared will be equal to 0. This is in the case when, sorry, not 0, it's 16 minus 8. That is equal to 8. Okay, so now x Over here, x will have the value of plus minus 2 root 2. Therefore, the point of now it's given that the point of intersection is in the fourth quadrant. Point of intersection lies in the fourth quadrant, which means both x is positive and y is negative. So what will be the value? X is positive 2 root 2 and y is negative, that's minus 2. So this is the point of intersection of both of them. What we need to find in the question is the angle between the curves at the point where they intersect. So now we have to find out the angle between the curves at the point of intersection. So here m1 is equal to dy by dx at this point, that is given by minus 2 into 2 root 2 upon minus 2, that is equal to 2 root 2. Similarly, slope of the tangent, second one, m2 is given by dy by dx is this, which is given by 2 root 2 upon 4 into minus 2, which is minus root 2 upon 4, or this. Let's find out the product of them. m1 into m2, that's 2 root 2 multiply minus this, which is equal to minus 1, which simply means that they are perpendicular to each other, right? So these two curves are they are perpendicular to each other. That means the angle between them, angle between curves is equal to pi by 2. Okay, so I'll just explain what we have done again. The angle between these two curves, first of all, these are the two curves. I found the slope for the both curves. And for the point of intersection, I just using the equation of the two curves, I found the point of intersection of the two curves is equal to this. Now you have to find out the angle between the angle where the two curves intersect with each other. So this is the for curve 1, this is the slope at point 2 root 2 minus 2. This is the slope for m1. And the second curve has this slope at the same point. The product of the slope came out to be minus 1, and you know the product of two curves, it's minus 1. That means the angle between them is equal to pi by 2. So that is it. We have option B as the answer. Hope you understood. Next is question number 74. If the function fx is equal to x into x plus 3 e raised to power minus x by 2 satisfy all the conditions of the Rolle's theorem in minus 3 comma 0, then a root of f dash x is equal to 0 is. You are given fx is equal to x into x plus 3 into e raised to power minus x by 2. This can be written as x squared. I'll take x inside plus 3x e raised to power minus x by 2. Let's find out the first derivative now. So this is 2x plus 3 e raised to power minus x by 2 plus x squared plus 3x e raised to power minus x by 2 multiply by minus 1 by 2 is equal to 0. I'll take e raised to power minus x upon 2 common. You will be left with 2x plus 3 minus x squared plus 3x upon 2 is equal to 0. Or this can be written as, let's solve it, 4x plus 6 minus x squared minus 3x upon 2 is equal to 0, which gives you minus x squared plus x plus 6 upon 2 is equal to 0. See here, you can have x squared minus x minus 6. That's equal to 0. Why? Because e raised to power minus x by 2, this cannot be 0 because x belongs to minus 3 comma 0. It's given in the question. Therefore, only this expression is equal to 0. So let's split the middle term. You have x squared minus 3x plus 2x minus 6 is equal to 0, which make the two factors as x minus 3 and x plus 2, which means x may be minus 2 or 3, right? So that means it belongs to what the question was, if the function this satisfies the condition of the role theorem, then a root of, okay, f dash x is equal to 0 is, what is a root? We have the two roots, right? And moreover, it is given in the question that the range is -3, 0. So that means 3 is not allowed. I'll check only x is equal to -2, which is option C. Hope you understood. Next is question number 75. So we have a trigono problem. Integral, actually integral also, integral of dx upon sin x plus cos x is equal to what? Okay, so you can write down, I'll write this as, I'll start from here only onwards. So this is as dx upon sin x can be written as 2 tan x by 2 plus 1 upon 1 plus tan square x by 2, and cos x can be written as 1 minus tan square x by 2 upon 1 plus tan square x by 2 dx. Okay, dx is already written. Now further, I hope you know the two formulas. Sin x is equal to this and cos x is equal to this. Now further, this is equal to 1 plus tan square x by 2. It will come in the numerator, right? Dx whole divided by 2 tan x by 2 plus 1 minus this. Now, you know 1 plus tan is equal to secant square x by 2. And the denominator can be written as 2 tan x by 2 plus 1 minus tan square x by 2. So here now I'll put tan x by 2 is equal to some t, which gives you, let's find out the derivative, secant square x by 2 dx is equal to 2 dt. See, over here, actually it was half, which I took on the right hand side. So it becomes secant square x by 2 dx is equal to 2 dt. Now this integral will become integral of, I'll take the 2 outside, dt upon 2t plus 1 minus t square. That is equal to -2 dt upon t square minus 2 minus 1. That is further equal to -2 dt upon t minus 1 square minus root 2 square. That's equal to 2 dt this minus this. So let's find out the integral now. This is the integral of log root 2 plus t plus minus 1 root 2 minus t minus 1 multiplied by 1 upon 2 root 2 plus the constant c. Okay, so they will cancel and I will have 1 by root 2 log of, now let the put t is equal to tan x by 2. This will be root 2 plus tangent of x by 2 minus 1 root of 2 plus minus, sorry, root of 2 minus tangent x by 2 plus 1 plus the constant c. So that is equal to 1 by 2 log 1 by root 2 log tangent of x by 2 plus root 2 minus 1 upon 1 minus tangent x by 2 plus root 2 plus c. You know one thing, tangent of pi by 8 is equal to root 2 minus 1. And cotangent of pi by 8 is root 2 plus 1. So I'll use both of these in over here. So this is equal to half, sorry, 1 by root 2 log tangent x by 2 plus tangent pi by 8, 1 minus tangent x by 2, and this becomes over here root 2 plus 1, that is equal to plus cotangent pi by 8 plus c. That's equal to 1 by root 2 log of c. This is the formula for so this is equal to tan x by 2 plus tan pi by 8 whole divided by this is 1 upon tan pi by 8 minus this plus c, which is 1 by root 2 log of tangent x by 2 plus tangent pi by 2, 1 minus tangent x by 2 tangent pi by 8 whole multiplied by tangent of pi by 8 plus the constant c. Right. This further will be written as 1 by root 2 log of tangent x by 2 plus tangent pi by 8 upon 1 minus tangent x by 2 into pi by 8 plus 1 by root log of tangent pi by 8 plus the constant. This can be written as 1 by root 2 log of tangent x by 2 plus pi by 8 plus the constant c. Right. So let's look at the options. You have option A as the correct answer. See, in this option, I have you. There is a c over here, and this can represent just any constant. So I have represented that constant by c dash. Doesn't matter. So basically, what matters in the question is the variable part, which is option A. Hope you understood this. Next is question number 76. You have to find out integral of the given function dx. Let this be equal to I. In this, I'll put x plus 3 is equal to t square. So you will have x is equal to t square minus 3, which will give you dx is equal to 2t dt. Therefore, the integral can be written as t square minus 1 into 2t square dt. Right? Question number 76, you have to find the integral of the given function. Let's say this is equal to I, and in this question, I'll put x plus 3 is equal to t square, which gives me x is equal to t square minus 3, or dx is equal to 2t dt. Here, the integral I will be given by integral of t square. See, x plus 2 can be written as t square minus 1 into root of this, that's equal to t, and this can be written as 2 into 2t dt. Dx can be written as 2t dt. So this will be integral of t square minus 1 multiply 2t square dt. Let's find out the integral. First of all, you will write it as 2t raised to power 4 dt minus 2t raised to power 2 dt. That is equal to 2 into t raised to power 5 upon 5 minus 2 into t raised to power 3 upon 3 plus the constant c, which is, I'll take it common like LCM, 2 upon 15, 3t raised to power 5 minus 5t cube plus c. So further, this is equal to 2 upon 15, 3. Let's fill in the value of t, that is x plus 3 whole square, and this is raised to power 5, so this can be written like this, minus 5 into x plus 3 into this. Okay, plus the constant c. Correct. So this is equal to 2 upon 15. I'll take root of x plus 3 common, 3. I'll open this. So this is x squared plus 6x plus 9 minus 5 into x plus 3 plus c, 2 upon 15 root of x plus 3, 3x squared, 18x, 27 minus 5x minus 15 plus c is equal to 0. 2 upon root 15, root of x plus 3, 3x square plus 13x plus 12 is equal to 0. So that's the answer to the question. Sorry, not is equal to 0 plus C. So that's the answer to the question. Let's check. You have option B as the answer. Hope you understood this. Then next is question number 77. If integral of 1 minus cos x raised to power 2 by 7 upon 1 plus cos x raised to power 9 by 7 dx, you have to find it out. I can write it as, this is a given expression. This can be written as integral of 1 minus cos x raised to power 2 by 7 upon 1 plus cos x into 1 plus cos x raised to power 2 by 7 dx, which, this is equal to simply integral of 1 minus cos x upon 1 plus cos x raised to power 2 by 7 into dx upon 1 plus cos x. Now, that's equal to 2 sine square x by 2, 2 cos square x by 2, whole raised to power 2 by 7 into dx. This can be written as 2 cos square x by 2. 2 and 2 will cancel. You will have integral of tan square x by 2 whole raised to power 2 by 7 multiplied by half secant square x by 2 dx, which is integral of tangent raised to power 4 by 7 x by 2 multiplied by okay, I've taken this outside, so secant square x by 2 dx. Now I'll put x by 2 is equal to 2 t, sorry. So secant square x by 2 dx will be equal to 2 dt. Sorry, tangent of x by 2. I'm putting tangent of x by 2 is equal to t. I'll write it down again. Okay. Now let's get back to our integral over here. This will be integral of t raised to power 4 by 7 multiplied. So this 2 and this 2 will cancel, dt. That's it. So I'll write it again, t raised to power 4 by 7 dt. On opening this, you will have raised to power 1 upon raised to power divided power. That is equal to t raised to power 11 by 7 whole divided by 11 upon 7, which is equal to 7 upon 11 into t raised to power 11 upon 7 plus the constant c. Okay, we have to refill the value of t, that is 7 upon 11 into 10 tan x by 2 raised to power 11 by 7 plus t. This is answer to the question. Let's check. You have option A as the answer. Hope you understood this. Next is question number 78. So again, an integral problem. You have to find out integral of this whole given expression. Okay. So here you are given this thing. Let's write it down. This is integral of limits 5 to 9 log 3x square dx whole divided by log of 3x square plus log of, I'll take 3 common from here. So if you will take 3 common, this will be 196 28x plus x square. So that's from 5 to 9 log 3x square dx upon log 3x square plus log 3. Now this is the square of 14 minus x whole. This is a perfect square, 14 minus x whole square. Okay, dx. This is equal to limits from 5 to 9 log 3 14 minus x whole square dx upon log 14 minus x whole square plus log 3 14 minus x whole square. See, what I'm using over here is this rule or formula. Limits a to b fx dx is equal to limits a to b f of a plus b minus x dx. So this has been applied over here. Next, this integral becomes, if I'm saying this is equal to I, next this integral becomes limits from 5 to 9 log of 3 14 minus x square dx upon log of 3 14 minus x square plus log of 3x square. Let's name it as 2 and the starting one, this one as 1. So now adding both of these equations. Adding 1 and 2, you will get 2I is equal to limit from 5 to 9 log 3x square plus log 3 14 minus x square on log 3 14 minus x square plus log 3x square dx. This is equal to, simply they will cancel out numerator and denominator and you will have 1 into dx. So that is 5 to 9 or 4. So d2I was equal to 4, which gives you I is equal to 2. That means we have option A as the answer. Hope you got that. Let's move to the next question, number 79. Integral minus 1 to 1 log 1 plus x upon 1 plus x square dx is equal to this plus this. Then you have to find out the value of fx. Okay. So actually the sum is not tough, but it has to be done very carefully. Limit minus 1 to 1 log of 1 plus x upon 1 plus x square dx. It's given to you. It's equal to this 0 to 1 limit log 1 plus x upon 1 plus x square dx plus limit 0 to 1 fx dx. Okay. Now this is minus 1 to 1 log 1 plus x upon 1 plus x square dx plus integral 0 to 1 upon 1 plus x square dx. Sorry, this is, I'll take it from this. Okay. Now this can be, this LHS can be written as minus 1 to 0, this plus 0 to 1, this, right? And now this whole thing is equal to integral of 0 to 1 log 1 plus x upon 1 plus x whole square dx plus 0 to 1 fx dx. Which further will be written as integral minus 1 to 0 log 1 plus x 1 upon 1 plus x square dx plus 0 to 1 log 1 plus x upon 1 plus x square dx. This is equal to integral 0 to 1 this and fx over here. Right. So further, let's solve this. So here these two will cancel out and you will have integral minus 1 to 0 log of 1 plus x upon 1 plus x square is equal to 0 to 1 f of x dx. Okay, now let's say this is equal to some I. I'll put now x is equal to minus y. That makes dx is equal to minus dy. So when x is equal to 1, y is equal to 1. And when x is equal to 0, y is also equal to 0. The integral now 1 to 0 log 1 minus y upon 1 plus y square dy. So now by the change of variable property, this happened by using change of variable property. By using this will become I is equal to 0 to 1 log of 1 minus x upon 1 plus x square dx, or 0 to 1 fx dx is equal to 0 to 1 log of 1 minus x upon 1 plus x square dx, which gives you nothing but fx is equal to log of 1 minus x upon 1 plus x square. That's it. Which we have in the options is option C. So this is the correct answer to the question. Hope you got that. Next is the last question of this paper, question number 80. The general solution of this equation is, so you are given dy by dx is equal to x plus sine x cos y this. This is the whole expression which is given to you. Let's write it properly. I'll take x common, 1 plus cos y, and sine x common, this. So the two factors are this, right? This is equal to dy by dx, or dy upon 1 plus cos y is equal to x plus sin x into dx. Here, dy, this can be written as 2 cos square y by 2 is equal to x plus sin x dx, or that's equal to half secant square y by 2 is equal to this. Now integrating on both the sides, you have that will be half into tangent of y by 2 divided by 1 by 2. So this 1 by 2 and 1 by 2 will cancel. That's equal to x squared by 2 minus cos x plus the constant, which gives you tangent of y by 2 is equal to x squared by 2 minus cos x plus c. So this is answer to the question. Let's check. Here you have option B as the correct option. Hope you understood this. So students, with this, we have completed all the 80 questions of this paper. Hope you understood them well. You can rewind the video and re-see all of the things which like you have any problem, or please put your comments, put your suggestions in the comment box. So a very best of luck, students. Keep shining, keep rising high. A very best of luck for your exams, and don't forget to visit our website www.examsnet.com. There you will find similar type of multiple entrance exam question papers with their solutions and PDFs. You can also download our app. The link is available in the description box. So a very best of luck. That's all for this paper. Bye.